Is audio, video all clear? Okay? Okay. So, yes, all clear from this side, from the technical team, all okay. You can also say from all the campus, okay? Yes. Yes, good morning. So, these are the chapters that we are going to cover, okay? Here in 11th, if I say, then we have here your unit measurement and means all are the already the chapters. If I say weightage wise, because ultimately you need to know the weightage also, how much questions they are going to be, they are going to ask from each, already but in the quickly I will say, from the unit measurement, you may, expect almost around 3, you can say, one question can be from the unit, one can be from the measurement like screw gauge, vernier calipers, one can be from the error. Earlier there used to be 2 questions when they give your section B, means 50 questions, then they are asking 3 questions from here. Gravitation, we can say 2 questions can be there, and properties of matter and fluid mechanics, means in this one we have the elasticity, we have surface tension, as well as your statics and dynamics is there. So we can expect 3 from here also. Thermal physics, in thermal physics we have thermodynamics, we have KTG, we have your heat transfer, you have thermometry, you have calorimetry. So these 5 subtopics, minimum 3 can be expected. Minimum 3 I'm saying, sometimes they are going for the 4 also. So minimum 3, and you can do all these all 3 questions from here also. Thermal physics, oscillation plus wave. I will not say that oscillation plus wave is actually 3 questions. Sometimes 2 here, 1 here, or 2 here, means 1 here, 2 here, like this they can divide between the oscillation and wave motion. Ray optics and wave optics combinedly, ray optics plus wave optics, I can say it is okay. And you can say almost 5. EM wave can be the one. Photoelectric effect, or I can say total modern can be almost total modern, we can say around 9 to 10 questions can be there. Yes. Yes. So now we can say here in this one, let's go for the things here. I think where he kept the files. Okay. So now we have, first of all, we'll start from the, because 11th and 12th class weightage actually, if you say 11th and 12th class weightage, 12th is somewhat more, 11th is slightly less. We can say 45 and 55, 55 for the your 12th, 45 for the 11th, and in the 12th will start, because mainly we have to cover the whole modern physics all the time is scoring. So we are going to start with the modern physics. We'll be going with the modern physics, and then we'll go for the optics, and then we'll go for the your 11th. So yes, it will be much better for the modern. So in the modern, I will go for that chapter generally people ignore, and most important, that is the your coming semiconductor. So we'll be starting from semiconductor first of all. Little bit theoretical, means almost a lot of things are in the theoretical here in this semiconductor. So now, so in this one basically what we will do, whatever important points are there, that we will cover. All the solved example of NCERT will be covered, as well as if some more other questions also needed, that also will cover. Or if you also want to you want to ask something, that also we can take it. So now, in a semiconductor, first of all, you need to know that why we are using the semiconductor. Anyone can ask that, what is the problem? Are there, before the semiconductor devices, we were having the vacuum tubes. You might have seen the thick TV at your home, quite thick TV, Those were the vacuum devices, vacuum tubes, but these were the bulky, consuming very high power, and they were operating at the very, very high voltage, so their life was also less. and reliability was also not more. You might have seen those TV, thick TV, but basically your okay, maybe max to max 1 year, then we have to change the picture tube, 1 or 2 year we have to change. Okay, now we having the your LED system that is going for the your 5 year, 10 year like this. Okay, so those vacuum devices were not okay quite good. Now in the semiconductor, basically what is there, we don't have any external heating or large evacuated space. They are always small in the size, consuming low power, so they are efficient also. You can make very short notes also for these, because some theoretical points are there, whatever. Okay, like vacuum devices not good, semiconductor devices good, because okay, they are small, they are consuming less power, they are operating at the very low voltage. Yes, there are okay, reliability is more. Okay, so semiconductor devices are preferred here. Now what are the basically your material classification? Everyone knows metals, semiconductor and insulators. Okay, we are having this classification based on the conductivity. We can say okay, your conductivity of metals, okay, conductivity of metal slightly more, it is more. Semiconductor in the between, and insulator have very less conductivity. These values not needed. Okay, no need for these values, just you remember that conductivity things. Okay, now we have type of semiconductor. Here in this one we can have your elemental semiconductor, compound semiconductor. In the elemental, only silicon and germanium that we are using. Fundamental semiconductor, silicon, germanium, everywhere, these are the elemental. And then we have some compound only, you know, okay, that will mix 1 or 2. Okay, so in that one we have your CDS, GaAs, gallium arsenic phosphide, you might have seen we will use in the LED. Okay, CDSC, INP. Okay, so these are the inorganic. These are used for the special purpose diode, like LED is there, solar cell is there. Okay, in which silicon, germanium cannot be used. So that are your compound semiconductor. Then we have organic also as well as inorganic also, means inorganic as well as organic. Just in short you have to remember, inorganic means okay, already these names are there. Organic means some okay, this name is there. Okay, so just here keep in the mind. Okay, nothing to take much load of this thing, because mainly we are going to focus on the silicon, germanium as well as inorganic semiconductor. Organic semiconductor, organic polymers are still the okay in the research phase, so we don't have to go there. Now basis of energy band, but now energy band we are not going to discuss also. Okay, so energy band I will skip. Directly we go for the P type as well as okay your N type. First of all, you have to remember this diagram. Okay, now these diagrams are basically your based on the energy band. One is the conduction band, one is the your valence band. Conduction band, you have to remember wherever conduction electrons are there. Conduction electron means free electron. Whenever you give energy, then what happens? Electron breaks bond, and whenever electrons are breaking the bond, they become free. These free electrons are known as conduction electron. We know your current mainly because of your conduction electron. They can move anywhere in the lattice. Okay, so freely moving anywhere in the lattice, those are your conduction electrons. Okay, so we can say conduction electrons are having slightly more energy. So set of energy level of conduction electron is known as your conduction band. Conduction band is not the one physical structure. Lot of people have this doubt that okay, this is your balance and this is your conduction. This is the physical structure. No, these are your energy levels, set of energy levels. Okay, like we can say, so when you are sitting in the classroom, your energy level, everyone sitting in the classroom don't have the same energy level. Someone is having slightly more energy, someone are having slightly less energy. So your energy is ranging from suppose 10 to 20. So we can say this set of energy level is basically energy level of the bounded students. And then we can say okay, in the classroom some of the students suppose moving, these moving are known as your conduction or free electron, and all the moving also will not be having the same. So their set of energy level is basically known as your conduction band. So they are the okay set of energy level. Okay, in the metals what happens basically, this A okay is for the metals. In the metals already these free electrons exist, means we don't have to give any energy to make them free. Already they are free. So there is okay no difference between the conduction band and valence band, because already that energy is not needed. We can say here that if this is the, we can write in this one. Yes. So if I say this is the your okay, this is here valence band and this is the conduction band. This one is known as your gap. Okay, and this gap is basically energy needed to transfer electron from VB to CB. When I say transfer electron from VB to CB, it only indicates and minimum energy needed to make electron free. Energy needed to make electron free. That is the meaning of the gap. Gap does not mean one physical thing. Energy needed to make the electron free. So that is the your delta Eg. In case of metals already free, so there is no gap. Even there is the some overlapping is for the metals. Delta Eg written here, that is almost zero. Okay. Almost zero. For the metal, already free electrons exist, so that gap is not needed. We can say that second is for the insulator. For the insulator, we can create free electron, but this requirement of energy is more than 3 electron volt. Huge gap is there, huge energy is needed. In case of insulator, if you are supplying your more than 3 electron volt, then we can transfer electron, we can make some of the electrons free, but energy is huge. In case of semiconductor, this is your less than 3 electron volt. Like if I say for the your silicon, so for the silicon, how much energy is needed basically? What is the gap for the silicon? You can say 1.1 electron volt, and they can ask delta Eg for the germanium is basically 0.7 electron volt. Okay. So here one question comes that insulator as well as semiconductor. Insulator and semiconductor, if we increase temperature for insulator and semiconductor, their conductivity increases or decreases. We can say on increasing temperature, some electrons will be transferred, some electrons will become free. Electron becomes free, so it will increase. It happens in both cases. In here requirement is less, here requirement is more. Okay, so here very less number will be there, so here conductivity is going to be very less, and here we can get significant conductivity, whatever is needed for us. Okay, so you have to remember. I hope you remember this one. Now, second question coming, because when you have energy, they can ask the question of wavelength also. Energy is always equal to 12400 divided by your lambda. So they can say that band gap for a semiconductor material is 2 electron volt. Band gap is 2 electron volt, and what are the wavelength needed? What are the wavelength? Okay, which can transfer electron from VB to CB, means which can make free electron, which can increase the conductivity. They can ask like this, which can increase the conductivity, which can make free electron, or they can say electron transfer from VB to CB. So we have to use this one, that lambda equal to, we can write here 12400. Band gap they have given 2 electron volt, so we can say 2. Answer becomes in this one how much? 6200 angstrom. Remember, in this formula, energy is always in the electron volt and lambda is always in the angstrom. I hope you can remember this thing. Energy in the electron volt and lambda in the angstrom. I hope everyone is clear with this thing. Okay, this is the one simple question coming here. Okay, so till now we got a classification between the your metal, insulator and semiconductor based on the energy gap. Okay, now, so this already we have seen whatever is there. Now we have intrinsic semiconductor. What are the intrinsic semiconductor? Purest form of silicon, germanium. If you take pure form without any mixing, without doing anything, pure form, that is the your So in the intrinsic, if I say, then we can write that if I talk about this is the conduction band, this is the your valence band. So we can say at the 0 Kelvin, is there any thermal energy available to break the bond? At the 0 Kelvin, there is no energy available to break the bond. So no bond will be broken, no electron is free. Any electron is free? No electron free. So remember, at 0 Kelvin, any semiconductor, at 0 Kelvin, intrinsic behaves like a semiconductor, yes? So it will act like, at 0, this is the one point, at 0 Kelvin, it behave like insulator, because nothing is there, no free electron, no energy is there to, break the bond. Then what happens basically, that at some room temperature, as the temperature increases, written here, as the temperature increases, more thermal energy becomes available to these electrons, and some of these electrons may break away, these bonds, becoming free electron, contributing to the conduction. So we can say then whenever some electrons will become free, so what will happen here? Your electrons you will get, and whenever electron will leave the lattice, whenever electron will leave the lattice, it will create one hole. So in your here we can say hole is created. Hole is nothing but the deficiency of electron. 3 electrons free, 3 holes, 4 free, 4 holes are there. Okay, so you can say, sir, in this case NH and Ne both are same. Yes, both are same. NH equal to Ne, both are same. Okay, for the intrinsic both are same. Okay, now we can say here in this one that is written here that this vacancy with the effective positive electronic charge is called hole, and hole behaves as apparent free particle, and we know Ne equal to NH. Okay, this is also known as your Ni also. Ni means intrinsic concentration, and I means basically I can say intrinsic concentration. What the meaning of intrinsic concentration here? That in the purest form, how many electrons are there? Exactly the same number of holes will be there, and that concentration of electron, either hole, you can refer as the intrinsic concentration. Suppose we have 1 million electrons, you will be having 1 million holes also. That is your intrinsic concentration. Okay. Yes. So now we can go for the next thing here in this one. You have to remember one more formula that we'll use later on. Ne into NH equal to basically Ni square. Okay, we'll use this one. This formula we'll use to calculate number of electron and holes. So Ne into NH equal to Ni whole square. Okay, Ne into NH equal to Ni whole square. Clear? Yes. Ne into NH equal to Ni whole square. So in the intrinsic, you remember 4 points are told, only 4 points needed here. Okay, because only we are going to just take the important points, whatever the that whole juice is there that we have to take. So keep maintain, write in your notes also, revise, keep on revising. And you will see that yes, in the final examination, questions, lot of questions you will be able to do from here. So we can say first we got that at the 0 Kelvin it will behave like the insulator because there is no electron free. At the temperature will increase, they will break the bond, some of the electrons free. So a number of electron holes both are same. That is known as intrinsic concentration. And then we have seen Ne into NH equal to Ni whole square here. Okay, one point you have to remember, just you have to remember, I cannot explain here. So you can say Fermi energy, because electron and hole both are same. So Fermi energy will be between this. Okay, Fermi energy will exist between this. Okay, in the middle of this one. Fermi energy will be the middle of this. Okay, that is not written, but yes, you can remember Fermi energy level will be in the middle of this one. Okay, so this is the thing about your intrinsic here. Now listen, one more thing. Lot of people think, lot of people think in this one that hole is also moving. Listen, hole is not the real thing, hole is the virtual thing. So remember, it is written here, remember that motion of the hole is only convenient way of describing the actual motion of the bounded electron. In the classroom you have done the example that free electron can move anywhere. Sometimes what happens that which were the bounded students sitting in the back will find that there is some space in the front or second row. So from the last row they will come so they will come and then they will sit in the second or first row. So basically this is the motion of your bounded electron, and motion of the bounded electron we will represent with the hole. So now we can say, is that enough? Is that enough? You can check, almost each and every point we are covering. Of course it is enough. But whole year, if you have done the things, then of course it is 100% enough. And if whole year also not done, then do it seriously, and then you will find some difference at the end of the lecture in your life. Yes, today I learned something. I'm confident about this thing. Just you will within 5 means after the 5 hour you will get some difference. Yes, today I learned something. Even though you didn't know anything, then also some differences will be there. Some of the questions 100% in the NEET, when you will sit in the paper, you will say, yes, I know. Because from the NCERT they are going to ask a lot of things. That's why I'm mainly focusing on the NCERT now. So we can, other than the NCERT also I'm taking, if something is needed. So we can say that electrons means free electron, we can say, and hole means basically bounded electrons. So two things are there. One is the free electron moving and one is your bounded electron moving. So bounded electron we can represent with the hole. Now you will tell me that which will be moving faster, bounded electron or free electron? which is having more mobility, bounded electron or free electron? Of course, we can say this is the your 100% free electron. So free electron means electrons have more mobility than holes. You have to remember, okay? Electrons have more mobility than holes, okay? Everyone will remember. Electrons have more mobility than holes, okay? And we know current is formula is this NEA VD. You remember this one, NEA VD, where VD is basically mu E. VD is mu E. VD means drift velocity depends on the your mobility. So current because of hole will be more, or current because of electron will be more. So we can say contribution of the current is basically current is coming. We can say total current coming okay, from the electron as well as hole both. Total current coming from both. But which one is more? If they are asking that which one is contributing more, then we can say electron contributing more. Electron contributing more. Okay, so you have to remember this one. Yes, you can remember VENA also, VENA, okay, or any formula. Electron contributing more. Okay, so contribution coming from both. So this is written here that I equal to IE plus IAH. Okay, so both are there, but we can say electrons are contributing, okay, slightly more due to the, okay, more. Now next is basically here one example coming here, that carbon, silicon, germanium all have same lattice structure. They belongs to the fourth group. But why C insulator and silicon, germanium are the intrinsic semiconductor? Reason being, down to the gap, down means down to the group, your band keep on decreasing. So for the carbon, gap is huge gap is there. Reason is because in the carbon, all the valency electrons are very close to nuclei. If you see the carbon size is basically what? Less. So all the outer electrons are very close to nuclei, and very close to nuclei means it is going to hold very tightly, and when it will hold very tightly, then it will not make them free easily. So basically we can say carbon, it is very tough to make the electron free, while silicon somewhat easy, 1.1 is only needed. Germanium even easy, even very easy, that is the 0.7 needed. And then we can say others, okay, your SN and PB, they behave like your metalloids also, means they have some metallic character also. Okay, extrinsic means whenever, okay, we will depend, means we will, when we are going to mix some impurities, when we are going to dope something. Doping is mixing some impurities, that is known as your extrinsic semiconductor. And for the extrinsic, I can say if you are mixing your pentavalent, okay, like this, we can mix the pentavalent or we can mix the trivalent. When you are mixing the pentavalent, we get, okay, you have to remember this line only here, that when we are mixing this thing, okay, pentavalent, okay, then we get n-type, okay, because question they will ask that when we get n-types, we can say this is the there, you can say the n-type. And okay, these example you will remember, okay, for the fourth group. And if we are having this one, then we are getting your p-type. Okay, this is the your p-type. So next thing, okay, in this pen I will just okay, directly I will go here in this pen. I'm not going to take this thing here. In the p-type, n-type, I will explain slightly here, okay, because same thing I have to say. It takes in the p-type basically, okay, using this diagram I will say this one is the your CB, this one is the your VB. Okay, so in the p-type your holes are slightly more. Okay, so we can say number of holes more. Okay, number of holes more. Why number of holes are more? Reason we know. Okay, so now we can say due to temperature, first of all, 3 electron and 3 holes. Due to temperature, due to the intrinsic nature, 3 electron and 3 holes are coming. This is coming due to the temperature, due to the intrinsic nature. When you mix the impurity, you are mixing trivalent. Trivalent is only having how many bonds? You can say 3 bonds are there. Okay, trivalent atom will be having, like if I take all aluminum, only 3. But you know, in the lattice of carbon, it have to make 4 bond. Without this, it cannot. Okay, it will feel I'm odd here. So it have to make the 4th bond. To complete its 4th bond, it will snatch 1 electron. It will accept 1 electron. It will try to take 1 electron. Whenever it will try to take 1 electron, its bonding will be complete. But when it is taking the electron, so there will be the excess of holes or deficiency of electron will be created. So we can say extra holes, these I am representing here. These extra holes are coming due to the, which one? due to the your okay, doping, these extra, that yellow number, okay, coming because of the your doping, okay, and this number is huge because of the temperature, that number is always very less. So we can say here in this one, you have to remember major electron, minor is the basically your holes, okay. And now in this one you have to remember one more thing that generally people forget here. When this aluminum will accept the electron, after taking that electron, it becomes positively charged or negatively charged. After taking that one, it becomes it will take the electron, okay, so it will become a positive ion or negative ion. Then we can see this aluminum, after taking the electron, becomes, after the taking, it becomes negative. So there is this aluminum, basically it have taken the, okay, electron na, so it becomes basically negative. This one aluminum cannot move because now aluminum, okay, already for the aluminum bond is done, so aluminum cannot move. So this one is known as immobile, okay, remember this one is known as immobile, okay, and this is the acceptor or donor, okay, immobile your acceptor, okay, immobile acceptor ion, which is the negatively charged. So three things are there: major, minor, as well as immobile acceptor ion, okay. Now in this one we can write here, okay, if I talk about the your this side, okay, this is the p and both I will write okay in one. This side I can write n type. In the n type, basically what will happen, I am going to mix the your pentavalent here, and here I will be saying, okay, this was the trivalent. When you will mix the, because of the temperature, we can see this is the Cb, this is the your Vb here. Due to the temperature, we are going to get some electrons and some holes. So some electron and some hole is coming due to the temperature, okay, due to the temperature, okay. Array, this is reverse written here. We see here majors are the holes, minor are the your electrons, okay. Now here we can see due to the temperature in this one, electron, okay, in holes 3 then in this one there is the your okay, pentavalent means we can say your like phosphorus. So it is having actually 5. So out of the 5, 4 it will use to make the bond, and this fifth one is still free. So fifth one it will donate, and when it will donate fifth one, then what will happen? Fifth one, okay, electron will be donated. Donated means this becomes free electron, and once it becomes free, so there is going to be excess of free electrons that I can write here. So there are so many free electrons here. Excess, huge free electrons are there. So we can say a lot of free electrons are there in this one. So you can say here in this one, if I say major, then we can say major are the your electron here, and in this one we can say minor are the holes here. And now this okay, pentavalent, okay, after donation of electron, it will act like positive or negative. We can say it becomes the positive, but it cannot move. So this is known as, we can say here, this impurity atom will be known as, we can say, your immobile, okay, it cannot move actually. So it is the immobile, okay, and donor ion, but this is the your positive, okay. This thing you have to remember, 3 things are there here and there, okay. Now we will say some more things in this one. Here if you say that acceptor how to take energy from the your Vb, it how to take energy from the Vb. So energy level should be very close to, okay, energy level of acceptor is very close to Vb, okay, very close to valence band, because it how to take in okay, it how to accept electron from here. So if this difference is huge, then electron cannot easily move. So this difference must be very less. It is okay, somewhere close to, if I say 0.05 is there, okay, 0.05, something like this, 0.1 I can say. This much very less gap is there. Now we can say here in this one, it have to donate to Cb. So here we can say energy level, okay, energy level of donor is very close to the your okay, Cb here, okay. So these are the some things that you have to remember here. Clear? Here we can say Ne into NH is basically, but number of holes, if I say na, here number of holes are almost equal to number of acceptor atom. I am saying almost equal. Remember, almost region, because holes are basically your these 3 plus other, okay, actually it will be your NH equal to, if I write the precisely na, Ni plus Na, but this Ni is very less. So remember, NH is almost equal to what? Na I will write, okay. Precisely this. Theoretically you have to remember this one, but numerical will use this one. NH is almost equal to Na, and here we can say that if Ne into NH equal to Ni whole square, I got here my NH I got, because they will ask what are the number of electron and holes. So NH I got, so we can find Ne will be equal to this one, Ni whole square divided by Na. So you have to remember, we'll use this one for the numerical, okay. Next one we can go here, same way I can write in this one also. Number of electrons will be basically your Ni plus Nd, but Ne I can say roughly, because Ni very less, equal to the Nd. So we can say here in this one NH will be equal to Ni whole square divided by Nd, because here electrons are equal to the donor, so they will ask about the holes. So we can say holes will be, okay, number of holes. These are the things that you have to remember. Yes. Any problem? Okay. Then one very critical question coming. A lot of people do mistake in this one. Okay. They say when intrinsic is converted to p type. When intrinsic converted to p type. Okay. When intrinsic, I can say, okay, this intrinsic, okay, I'm writing somewhat small, converted to p type. What happens to the number of okay, number of holes? You can see the number of holes increasing. Number of holes increasing, but what happens to the your number of electrons? What happens to the number of electrons? Oh, holes increasing because we are, okay, adding the acceptor, but number of electron does not, okay, it is not constant, it will decrease, okay. Number of electron will decrease. Reason is because recombination will happen, some recombination. Earlier there were the 5, earlier there are the, so 50 electron and 50 holes, intrinsic, 50 positive, 50 negative. When there is so much positive will be there, then what will happen? Some of the negative will combine, so that number will be slightly reduced. So remember, a lot of people are thinking that any constant, no, any is not constant, any will decrease. Same here, we can write then when you are converting this intrinsic to N type, then actually what happens, we can say that yes, NH, okay, means number of electrons 100% increasing, but in this case, okay, so much negative will be there, and when so much negative is there, if so much negative is there, then what happens? So much negative, because of the so much negatives, this positive number will be slightly reduced, okay. So NH will not be constant, it will be reduced. This is the whole thing written about the p type, N type. Anyone going to ask any theoretical question from here, you will be able to solve. Either numerical, we have the formula, we will do the numerical. Yes. So you are perfect in the p type and N type here. Going for the numerical. P type, N type is needed, okay, means which will be more effective, p type or N type? Which will be conducting more current? This question they have asked, okay, already. Which will be conducting more current, p type or N type? We can say N type will be more effective. N type is more effective, okay. Reason because N type is having your majority as electrons, so N type conduct more current. They, okay, can ask like this. This is the your P, this is the your N, okay, and both are connected to the battery, and then which will conduct more electron, okay, means more current. We can say this is the IP, this is the your I, and so we can say IN will be more than IP. Now they can ask ratio based question also. So for that you remember I, okay, P divided by I N equal to, we can say, N, okay, number of okay, or we can say hole here. So number of hole EA into VDE divided by, we can write NE, okay, EA into, okay, here we can write VDE. This is for the electron and this is for the holes. EA will be cancelled. They will give you the, this number will be given, this will be asked, and ratio of the drift velocity also given. So one numerical is coming from here also. They will say that ratio of the current due to electron and hole is 7/5 electron and hole, and then number density you have to find, and drift velocity they will give you. We can, okay, figure out this question also from there, okay. So now going for the NCERT again here, backstage, because for the semiconductor we set the target for the 45 minutes. Semiconductor will do in the 45-minute next, okay. Each chapter is having its time, so within 45 minutes we have to complete also. So now we can write next here. So this whole thing I have told in the, okay, for the P type and N type, whatever things are there, okay, done. So I will directly this, okay, this is written here that this gap is 0.01, okay, and this, okay, 0.01 or 0.05 begins, okay. So remember, this gap is not very, very huge. Already they told now that here, okay, this one is very close to the, okay, donor is very close to the your conduction band, and here very close to the your this one. Sometimes they can say that conduction means acceptor atom, this acceptor atom is okay 0.05 electron volt above than valence band. Then okay, find wavelength, okay, find wavelength, okay, of radiation. Then find wavelength of radiation, okay, which can create hole. Wavelength of radiation which can create hole means create hole means electron will become free. So they will give you that this is the, okay, where in the P type this is the your 0.05. So again same formula we have to use, lambda equal to 12400 divided by this gap 0.05 we can put, and we can get the calculation. Very less energy is needed to make the electron, okay, means to transfer this electron to create the hole in case of your P type. So this okay diagram you have to remember where energy levels are, okay, there. Then comes this question, very important, always see this one. They are saying a pure silicon is having these many atoms per meter cube, okay. So this is the basically your atoms. It is doped by 1 ppm, parts per million concentration, okay. Calculate the number of electron in holes, and they are saying in this one that Ni is given 1.5 into 10 power 16. First of all, we are doping with the your pentavalent, okay, pentavalent. So it will be the N type or P type. You can say, sir, this one is going to be N type, okay. It will be the your okay, I can say N type, okay, will be there, N type, okay. Next one we can write, if N type, okay, then in the N type number of electron is always equivalent to number of donor. So number of donor we have to figure out here. How will find the number of donor? You can say that in 10 power 6 silicon I am mixing unitary method 1 arsenic. What the ppm meaning? 10 power 6 silicon I am mixing only 1 arsenic, only 1 arsenic. ppm is okay. Then in 1 silicon how much I will mix? We can say 1 silicon I will mix 1 by 10 power 6 arsenic. And then we are having how many silicon? Total silicon concentration is given here 5 into 10 power 28. So you can write 5 into 10 power 28 silicon. How many will be needed? We can say 1 divided by 10 power 6 into here 5 into 10 power 28. And then this becomes how much? So 5 into 10 power 22 arsenic. These are the your what? Donor. And if these are the donor, that will be equal to the number of electrons. We can say this number becomes 5 into 10 power 22. So this is the number of electron, because they are asking both. Now we have to find number of holes. So we can say for the number of holes, we can use the formula Ne into Nh equal to how much here? Ni whole square. So we can write here in this one Nh becomes Ni square divided by Ne is Nd here. Ni given, I can put this one 1.5 into 1.5 into 10 power 32 divided by Ne we got here 5 into 10 power 22. This becomes here 0.3. So now we can say Nh if you write, okay, then we can write how much? This will be the 0.45 into 10 power 10. So it becomes here 4.5 into 10 power 9. I hope we can do like this. And this is the question that if they have to ask, they will ask exactly the same question. They can change the data. Okay, so it is always important. They have asked also previously. They can ask again also. So remember in the n type, they can just ask the same question for the p type. They have given n type, we know number of electron will be equal to the number of donor. For the p type, what will write? Hole equal to number of acceptor, and that we will find using this one. Unitary method is there, okay? ppm is 10 power 6 silicon, needed only 1 arsenic, and then 1 silicon 1 by 10 power 6. 5 into 10 power 28 silicon, we can say 1 by 10 power 6 into 5. So we got this much, okay? Arsenic is there. Means donor or acceptor depending on your p type and type, and then we have used the formula Ni whole square by n. You should practice this question one time, okay? Question can be for the p, either for n, exactly the same way, slightly change in the data, or maybe again same data also can be there. Yes. So this is one solved example here. I hope everyone have done. So next we'll be moving for the p-n junction, always important, okay? First of all, we cannot join p type and n type. P type and n type we cannot join to get the p-n junction, okay? We cannot join p type and n type to get the p-n junction. What we do basically, one side, okay, this is the silicon strip. One side we can dope with the your trivalent, so that becomes your p type. One side we can dope with the pentavalent, that becomes your n type. So one side is the p type, other side is the n type. You can ask why we cannot do, because flow of charge carriers will not be the continuous, that I can say. That's why p type and n type we cannot join, okay? Now as soon as you join, what happens basically, that I will just draw the figure here, then we'll read that point, okay? So in this one, we can say that this side we are doping. So this is the p side, p type, and this side I can say your n type. Okay. Now we can write in this one that this side we have your minus, and we have the holes. This minus, what is the indication of this minus basically? This is the immobile. Minus indicates immobile ion. Immobile means that cannot move. Okay. Again, remember, that cannot move, okay? That is the M minus means that cannot move. Some electrons also there or not there? Yes, some electrons are there or not there in this one. Some electrons also there, but these electrons are the minority. Remember, electrons also exist, but electron exists as the minority. This side I can write here that positive is there, positive immobile ions, okay? Electrons will be there, and these immobile ions cannot move, okay? Cannot move here in this one, so positive, and we can say here this one positive, positive. Here some these are the electrons major, some holes also there as the minority. So this is the formation we will do. Now what happens, as soon as you will make this one, you will see this side concentration of the holes is more, and this side concentration of electron is more, and you know that whenever concentration difference is there, then all the time particles will be moving from higher concentration to lower concentration. They are moving from higher concentration to lower concentration. That process is known as diffusion. So we can say, once we are making this thing, then diffusion of electron and hole starts towards each other. Diffusion of electron and hole start towards each other means they start moving towards each other. And when they will move, electron and hole are moving towards each other, then what will happen? You know, electron being the negative, holes being the positive, they are going to meet each other. Means they will make the bond, okay? They will make the bond in the real sense. So they makes the bond because electron and holes move towards each other. They move the some people are expecting, I will give some example. I am not going to give any example here. I will say simply that yes, electron holes move towards each other. So what happens? Okay, that in this in this region here, okay, in this region, electron hole recombining, okay, already recombined. So in this region only what is left basically, positive and negative immobile ions are left in this zone, okay? And this zone in which positive and negative ions are left is known as depletion layer, okay? This is the depletion layer that I have indicated. In this depletion layer, this side positive and this side negative, this side positive, this side negative. So we can say that here internal field is developed, but this internal field is in the your depletion zone, okay? Internal field is developed, and what the direction of internal field? This is from N side to P side. Internal is always from N to P, you have to remember, okay? Now what will happen, as soon as this internal field is developed, this will not, okay, this will not allow further this will not allow further diffusion, because these holes, when want to move this side, this field will apply force on this hole in the all the positive, okay, like this directions, holes cannot move, it will stop, it will try to stop. Electron also it will try to, okay, apply force like this. When they are near to the junction, it will apply force like this, so they cannot, means it will stop the diffusion. So diffusion will be slowly reduced, okay. So diffusion, it will oppose or suppose. Diffusion is opposing, okay. As of now, I'm not talking about any of the biasing here. Then these minority, what this field will feel that this side electron and this side holes, these are not, okay, safe here. So this means just I'm okay taking the joke here. And the electron and okay, these electrons, okay, because of this field which are near to the junction, it will apply force on these electron, will send this side, and it will send holes, these holes also, which is here this side. So we can say minority also, it will support the minority. So if I say this En basically your it will oppose majority, and we can say it is going to your support the, it is going to support the your minority. So minority is supported and majority is opposed. So because of the movement of minority, we are going to get the your drift current. Drift means slowly they will be moving. So slowly they will move. So we can say two types of currents are there. One is the diffusion current, okay, and remember diffusion current, okay, is from P to, and diffusion will be from this side, okay. If you find the net current P2N, and there is the drift current, okay. Drift current is basically your N2P, okay. Which is the major current? Major current is the your diffusion current. Earlier, which current was more? Diffusion current was more, okay. Diffusion current was more, and drift current is very less, because that is because of the minority, okay. So diffusion current is P2N, drift current N2P, and this is the your internal field N2P. In the depletion layer, is there any charge carrier? Charge carrier. What are the charge carriers? Charge carriers are the electron and holes. Immobile cannot move, okay. Immobile cannot move. So charge carriers are the electron and holes. So we can say in the depletion layer, electron holes not there. So depletion layer offers very high resistance or low resistance. Resistance is very high for the depletion layer. Depletion layer offers very high resistance. Remember this thing. Depletion layer offers high resistance, okay. Clear? Offers very high resistance, because in this one only positive negative immobile ions there, okay. Charge carriers not there. If any generated also, they will be, okay, quickly, okay, it will, internal field will separate them, okay. So high resistance is there. I'm going to separate here, okay, delete all the things here. I hope whatever is written here is clear, whatever I said. Okay, as soon as you will make diffusion is there, diffusion from P to N, okay, then internal field is developed due to the positive and negative ions. Internal field is there due to the positive and negative ions, immobile, and this internal field will oppose the diffusion and will support the drift, okay. But drift is due to the minority, so cannot increase very to the very large extent, okay. And the direction of the drift is N2P, and diffusion already written here, okay. So this is the whole thing written here, that whatever I have explained here, okay, that is written, okay. And now we'll read this one. Initially, diffusion current is large and drift current is small. As the diffusion continues, okay, as the diffusion, the space charge region on either side of the junction extend, thus increasing the electric field strength, and hence drift current. This process continues until the diffusion current equal to the drift current. Thus a PN junction formed in a, okay, under equilibrium, there is no net current, Net current is not there, because both become same. This side diffusion, this side drift, because diffusion was huge initially. Diffusion keep on decreasing. Drift was, okay, already very less, and as the strength will increase, slightly increasing, and then both becomes same. So net current is not there in unbiased case, okay. Now here we can say in this one, okay, here this is the field, okay, internal field N2P. So because of this field, there is always some potential, okay? Whenever field is there, we can say some potential, okay, it will be there. This potential is known as potential barrier. Why it is known as barrier? Because this potential tends to prevent the movement of electron from N region to the P region. That's why it is known as potential barrier, because this potential means with this field is developed due to the field is developed. This is the question they ask sometimes. Already we have asked this thing, that this field is due to, so this field is due to what? Positive and negative immobile ions, due to the positive and negative space charge, okay? Positive and negative space charge, we can say. Positive and negative immobile ions, we can say. Field is developed. With this field, there is always some potential, and this potential is having tendency to prevent the movement of electron. That's why known as potential barrier, okay? And this is the graph of the barrier. This side we can say high potential, and this side your low potential, you have to remember. And this difference is known as your, okay, barrier potential, okay? Now this is the question that already I have told you that we cannot okay, join. Now all the time you will, okay, remember that you have to represent diode like this. Everyone knows here, okay, that we have to, okay. Now then comes forward biasing and reverse biasing. Forward biasing means you will allow, okay, you will allow to meet. Reverse, you will not allow to meet, okay. So whenever you will connect this way, okay, I will just okay, right here. This means on the screen will be much better if I write, because otherwise, okay, it will take some time. So I will write the comparison of both. This side I can write FB is whatever you have to remember. This side I can write your RB, okay. In forward bias, actually, you will connect your P with the positive and with the negative. Means P will be high, okay. Potential of P you will keep okay, high than the potential of N. Means we can connect like this, and here, okay, you have connected this way, okay. This P becomes positive, this is the negative. Remember like this, okay. Here we'll do the reverse, exactly reverse, okay. That in this one we'll make P negative and N positive, okay. But listen, what are the meaning of this thing? Somewhere I will give the questions in which I will make both positive, na? With potential means okay, again reference both sides. So you have to check always which is high and low, okay. So I'm writing both the things for you. Means I can say this means basically your which is at high potential, potential of N will be more than potential of okay, P, like this. Means we can connect like this here, and then in this one P negative, and then this is the, okay. Now so you have to remember what here. I will make the diagram for this one. That here this is there, okay. So this is the your field here, okay. And now we can write in this one here positive and negative. I am connecting the battery. So when you will connect this positive and negative, so internal field is there. Because of the battery, there will be the one external field. Both are in the same direction or opposite direction. Here in this one, both are in the opposite direction, and both are in the opposite direction. The strength of this field will decrease or increase. It will decrease. Strength will decrease. Barrier will decrease or increase. Barrier also will decrease. And if barrier decreases, because barrier was stopping this flow. This flow was okay, majority flow was reduced because of the barrier. Barrier is okay, now reduced, so they are allowed to meet. So what will happen basically, that charge carriers now allowed to meet. Charge carriers will move towards each other. We can represent like this flow. They are moving okay, towards each other, okay. So if they are moving towards each other, we can say here in this one, diffusion current increases or decreases. Diffusion current increases, and we can say no major impact on drift. No major impact on drift here, okay. In this one, if I say that here, if you draw the diagram, then we can say that this is the field here, and this is the internal field. We are putting like this. So here positive, here negative. So external field will be in this one. This field, which was already strong, we are okay, applying one more external field in the same direction. Strength of the field becomes huge, and if strength of the field is more, then what will happen here in this one? Barrier becomes very high. Here barrier height becomes okay, barrier increases. Barrier will be too high that it will not allow any diffusion. Means here diffusion, which was already very less, diffusion becomes very less, means almost zero, and we can say no major okay, impact on a drift, okay, no major impact on drift up to some specific voltage, okay, up to some specific voltage. Region is there up to some specific voltage, okay. That voltage we refer as the your breakdown voltage. So no specific, up to some specific voltage. Now remember here in this one, that in this one number 2, here current is mainly because of diffusion, and here current is there, but that current is almost okay, because of the drift, and drift current is always 0. So this current will take 0, okay, almost 0. Drift is almost 0. I'm not writing equal to 0. Theoretically you have to remember, numerically 0. This one we can say very less resistance, and here we can say very high resistance, is there, okay. Here we have to remember in this one, width, okay, of depletion layer, okay, decreases or increases. Yes, width decreases, and here we can say width increases, okay, width increases. These are the points that everyone have to remember. Can you remember here? Yes, you have to remember, okay, this thing, that width more and here width less. Here barrier is, if I say barrier height here more, here we can say, if anyone is asking about the barrier height also, then we can say here barrier height is more and here barrier height is less, okay. Here barrier height will be less. Clear? So the whole thing about the forward and reverse, I will take some of the questions on this one, because now within 10 minutes we have to, okay, summarize this whole chapter. But once PN junction is over, we can easily finish the things. Okay, logic gate separately we have, okay, 15 minutes. Logic gate 15 minutes, but there is one question all the time. So remember these things, copy somewhere, okay. Now, so basically this is the graph that everyone have to remember. They will ask like this, that in this one you have to tell. So we can say clearly that in this one, maximum barrier height 1. So maximum barrier height is here. So we can say this one is the basically RB. This is the your lowest. So this is the forward bias, and this will be the your unbiased. Okay, means we can say this is the unbiased or no biased. Okay, so this graph should be remembered by everyone. This is the your okay height is too much, reverse height is very less, it is the forward, and height is the means in the middle. So we can say this is the unbiased. Okay, it is the unbiased. So this is the forward and reverse, everything I have told here. Okay, so now we can directly move for the, okay, yes. And remember in this one, okay, that in the reverse bias, barrier height will increase. Earlier it was 1, then it becomes 2. In the reverse bias, height will increase. Okay, always height increases. Okay, height increases. Okay. And now this is the graph basically here. You have to remember, this is the forward characteristic of the diode. And because we know that up to some specific voltage known as knee voltage, there is no change in the current, because you know that you have to cross the barrier. Everyone is having the barrier. So if you don't give energy, that minimum energy to cross the barrier, of course, no one will cross. So suppose barrier is 0.7. You have provided 0.7. You are providing 0.1, they will not cross. You are providing 0.2. Okay, they will not cross. Means everyone will not cross. Some are having, suppose some already having their energy 0.5. You have provided 0.2. They will cross. So everyone will not cross. If I say when everyone is going to cross, when you are providing that minimum potential, that is known as a knee potential. Okay, it's like 0.7. If you provide 0.7, then everyone is ready to cross. And when everyone is ready to cross the junction, then current will increase exponentially. So this graph is your exponential increment after the knee potential. This potential is known as here knee potential. You have to remember. In the reverse bias, if I, this is the forward characteristic. Okay, in the reverse, if I say, then the reverse there is no significant change, no change up to some specific voltage, because in the reverse. Reverse means basically already not allowed. Okay, you will apply 1, not allowed 2, not allowed 3, not allowed 4, not allowed 10, no one allowed. Okay, like this. But at one particular potential, what will happen that electrons will get energy and they will break their own bond. Okay, so many bonds will be suddenly broken, and when so many bonds are broken, then what will happen that lattice breakdown happens. This condition is known as breakdown, and suddenly so many carriers will be there that current will increase. So now we can see here that after this breakdown, current increases. Okay, current increases rapidly. This is known as your breakdown region. In the breakdown region, we use our Zener diode. Okay, remember, Zener diode is used in this zone. Okay, breakdown region. Okay, now these semiconductor devices are ohmic devices or non-ohmic devices. These are your non-ohmic devices because the graph is not linear. So non-ohmic devices, so they have dynamic resistance, and for that dynamic resistance is always given by delta V by delta I. Okay, means they don't have fixed resistance, they have the dynamic resistance. So delta V divided by delta I. Okay. Yes, they have dynamic resistance. Okay, the dynamic resistance means it will keep on changing. Okay, of course with the temperature also, with your biasing also it changes. Okay, with the forward bias and reverse bias. Forward bias very low resistance, and the reverse bias very high resistance is there. So with the biasing also resistance changes. So non-ohmic. Okay, and you have to use delta V by delta I. And remember, temperature will affect only one characteristic, means only forward, only reverse, or both. Temperature is going to change over all characteristic. Temperature changes over all. Remember, temperature changes over all characteristic. Yes. So already they have asked this thing. The temperature changes forward as well as reverse, both the types of character. Okay. Now, so we can see this one question is there here. That this is the given here. In this one, they are saying when potential is changing from here to here, okay, and then we are having current changes from here to here. They are asking forward resistance as well as okay, reverse resistance. So you have to use the same formula, your delta V by delta, okay, delta V divided by delta I. They are asking in this one that okay, you have to find ID equal to your 15 okay, 15 milliampere, and VD equal to how much here? Means ID equal to 15 milliampere. Listen, you have to find at the 15 milliampere, but for the 15 milliampere, don't take that V by I. You have to take the range. So now we can say for the A option, that from the curve I equal to, okay, how much? 0.8, okay, at this one, 20 basically 0.8, and at the 10 we are having how much here? 0.7, not written, but this is the 0.7, they will write, okay. 0.7. So we'll use delta V by delta I. So 0.7 to 0.8, that is basically how much change? 0.1. And here we can say 10 to 20 changes how much here? 10 milliampere. So R will write delta V 0.1 divided by, we can say 10 milliampere. So 10 power minus 3. That is your answer. Always you have to use delta V by delta I. Don't take this 15 divided by, okay, 15 by some values. No, delta V by delta I you have to take always, okay. Now, same is the part B also. Then comes uses. So first, okay, use is coming here, rectifier, okay. In the rectifier, two rectifiers are there. Mechanism, I will not say, of course, mechanism you know very well. If you know, very good, otherwise no problem, okay. Whatever I am saying, you have to remember. Two wave are there, one is the half wave, one is the full wave, okay. This is the diagram that you have to remember, okay. Here transformer, okay, transformer is just part of the circuit. Our main main focus is on this diode. This diode is acting like the rectifier, okay. So what is happening here in this one, that this is your AC you have corrected here, okay. So we are using this one basically a step down transformer. Why? With high voltage we cannot feed into diode. If you feed half, okay, if you are feeding very high voltage, then this diode will blast, burn, okay, it will burn out like this. So we can say that when positive cycle will come, okay, next time what will, okay, here positive means okay, here negative. So for the positive cycle, diode will be your forward bias. it will allow the current. Okay, so current will be coming in this load. But for the negative cycle, what will happen? Diode will become negative cycle, means we can say diode will be, okay, will not allow. So only positive cycle will be allowed. This is the, okay, mechanism. Positive cycle forward allowed, negative cycle reverse not allowed. Okay, so only positive cycle allowed. So you can say this one is the input signal given. So we can say in this one, when positive, negative, positive, negative, positive coming allowed, negative blocked. Okay, reverse bias, again positive allowed, negative, like this we are getting. Okay, so this one is the unidirectional, it is a DC. It is not the perfect DC, it is the unidirectional. Okay, unidirectional. And for the perfect DC, half wave, of course half wave, not the full wave, it is the half wave. For the perfect DC we do something, I will say at the last. Okay, so this is the your unidirectional we got. Okay, not the perfect DC here, it is in the ripple form. Output is basically in the ripple form. Okay, some ripple factor is there in this one. And you have to remember that if this is completing one cycle, then up to this is also completing how many cycle? One only. If you say up to this how completed how many? 1 and 2 cycle, and this also how completed how many cycle? 1 and 2. So we can say frequency of input is 1, output also 1. Frequency of if I say input is 2, output is also 2. Frequency of input is 100, output also 100, 50, and so this is the point that you have to remember. If frequency of input is n, output is going to be what? And frequency of input is and output also, and as it is, you have to remember, they will say the frequency of AC signal feeded to the your rectifier is 50 hertz. Then what will be the frequency of the ripple? Frequency of the ripple in output. What is the frequency of ripple in output? 50 hertz only. Input equal to output. Okay, input equal to output, as it is, you have to keep it. Okay, now, so next thing we can say, means this is the whole thing, just okay, they are writing there are the your okay, coming this one, this is the full wave. First diagram you have to see, diagram you have to remember, there are one diode, here we are having the two diodes. Okay, two diodes. So we can say that both the diodes will work alternatively, both the diodes are working alternatively. This is also known as center tap. Okay, center tap. Okay, you can, they have given diagram like this, and sometimes we can put like this also. Okay, directly also we can tap here. Anyway, diagram is this. Both will work alternatively. When positive will come, means here positive, then here negative. So what will happen basically, when positive cycle is there, then A becomes forward and B becomes reverse. So only A will conduct, and when A conduct, then we can say yes in the, okay, when only A will be active. Okay, I can, okay, so when A is active, then current, okay, coming like this, and then we can say yes, flow will be there. Okay, so we can say yes. And when negative cycle will be there, for the negative cycle we can say then negative cycle, A will be what? Reverse, and B will be active. So now we can write here what will happen for the negative cycle. Now B is active, so B will conduct in this one, and then like this. So at a time, which one is working? At a time only one is working, only one is working. Okay, so we can write here that positive cycle, as in this diagram, if you say positive cycle is coming through which diode, you can say positive cycle is coming through diode 1 and negative cycle is coming through diode 2. So we can say here in this one that this is the your AC. So we can say output is written here. So okay, positive cycle is coming due to the D1, negative cycle is coming due to the D2, this is coming due to the D1, this is the your D2. So both working together or alternatively, both are working alternatively. Only one is working is not true, both working alternatively. At a time, one working alternatively, they are working D1, D2, D1, D2, like this. Okay, so we can say here you have to remember that okay, this was the input signal I can draw. Okay, input was like this. So when this is completing one cycle, this is completing how many cycles? You can say 1, 2. This is completing, input completing 2. This is completing how many cycles? 4. So you have to remember, if input is n, if input frequency is n, then you have, okay, output frequency remain 2n. Input n, output will be 2n. Okay, output will be 2n, twice. Okay, twice of the input. You have to remember, it is written also here that if input is n, output is going to be 2n. Okay, 2n. Listen, this one is the DC, because main use of the rectifier, we say main use of the rectifier, we say basically, then what are the use of the rectifier? Rectifier means to get the DC, but this is not the DC. Previous was also not the DC. This is the unidirectional. This is a one direction, not in the both direction. This is in one direction, only one direction. Okay, one directional. Okay, so to convert the DC, we have to use your filter circuit. Okay, so we can see here in this one, this line you have to remember only this line. I will not go into detail of this one. Okay. So capacitor input filters are there to get the perfect DC. Okay, so you can see here in this one that to get perfect DC, what we are using basically capacitor filter to get perfect DC, to get smooth DC. Smooth DC means basically to remove ripples. So we can say to remove ripples. Okay, what we use basically to remove ripples, capacitor input filters are used. And what are the capacitance for that? Capacitance is large. Why capacitance is large? Filter circuit, remember the one line, filter circuit and their capacitor. Okay, capacitance must be large, so that time constant is more. I will not go into detail of the time constant, but time constant must be more. Okay, time constant RC, if C is large, time constant will be more. Okay, yes. So this is the and using the capacitor filter, what happens here, this becomes like this. Which are these ripples were there here, these ripples are reduced, and then we get the your almost smooth DC function like this. Like this we are getting. Clear? So to get the smooth DC, now this is like the DC, appear like the DC. Here ripples are reduced. So DC output, or we can say ripples are reduced using the capacitor filter. Then comes another use of this one, that is the Zener diode. Very important, Zener diode. First of all, you remember it is under reverse bias in the breakdown. And used for the voltage regulation, used for the voltage regulator. They ask what the use of this one. We can say used as voltage regulator. It is in the reverse bias, in the breakdown region also. And doping should be more or less. Zener diode is heavily doped. Zener diode is heavily doped. Zener diode is heavily very highly doped. Heavily doped. And remember, if doping, remember always, width is proportional to 1 by doping. Width is proportional to 1 by doping. So they can ask that if heavily doped, what will be the width? Width will be more or less. Then written here that due to this depletion region formed is very thin. And if depletion region is very thin, then electric field of the junction is extremely high. Extremely high. So these are the points that you have to remember. It will stabilize it will give you stabilized output. It gives the stabilized output. 4 points are there. Number 1 point, reverse biased, breakdown region, gives you constant voltage, so used as voltage regulator. Then highly doped, doping more, width less, so width is less. And in the depletion region, strong field is there, and you will connect always parallel to the load. So then this is the some value things written that already we know. So in the Zener, Zener will always give you the constant voltage, but current can be anything. Remember here, that's written here. Note that after breakdown voltage Vz, a large change in the current can be produced by almost insignificant change in the reverse bias voltage. In the voltage, insignificant change in the reverse voltage, insignificant change in the voltage means voltage remain constant. Zener voltage, listen here, this line, Zener voltage remain constant. Zener voltage remain constant. Even through current through the Zener diode varies over a wide range. Current can be anything, but Zener voltage remain constant here. That operating voltage remain constant all the time. So now we'll take one question. Fixed question is there. The question is also not changed here. So this is the whole theory written, and this is the one question. So in this one they are saying that in a Zener diode, supply a Zener diode with the 6 volt is used for the regulation. So I will draw the diagram for this one. Means we can say this is the your okay, here in this one this is the Zener, okay, and like this. Here we have the load voltage. So this is having 6 voltage. This is the load voltage, okay. Means not the load current, resistance. So load resistance is not given, I think. Okay, I think maybe somewhere here given. This is the series resistance. Series is always used to protect the your Zener. Series is always used to protect the Zener. Okay, I will take okay question separate. Okay, this question only I can take 6 voltage here. Then they say this is the 10 volt unregulated voltage. Okay, and you know if 6 volt here, then here also what will be there? Your 6 volt will be there. Okay, and okay, they have given here in this one that okay. One data also they have taken here. We can take suppose this data, okay, they have given or not given. A load current, okay, this one we can take some data here also. Better will be there. I can make this thing in the okay here. So listen, they will give you questions like this, that this is the series resistance, and then we got here this is the your Zener, and okay, this is the load. This is the your supply here, that is the 10 volt. Suppose I am changing data slightly. This one is the your 6 volt. Okay, here we can write in this one that is the your suppose I have given 2 kilo ohm. So now you know 6. Okay, here 6 volts. So here also across this also 6 volt will be there. But this one and this one, this one and this one are in the parallel, and if both are in the parallel. Okay, both are in the parallel. Yes, load current given. Load current given. I am changing the data. Okay, because they may not give the load current sometimes. They will give the load resistance. If load current given, then very easy. Okay, load current given, then very easy. Okay, yes. So now we can say this is the your 6 volt here. So we can say how much will be the load current. You can say load current IL becomes 6 by 2, which becomes how much here? 3 milliampere. Okay. Now in this one we can say out of the 10, okay, how much is used here? 6. So what will be the potential across this one? Here we can say across this potential will be how much? Across this potential I can take 4 volt. Okay, and they have given in the question of okay, in that question they have given that assume Zener current IZ equal to 5 times of load current. So we can say IZ we can take here 5 times of load, means 5 into 3, that becomes how much here? Your 15 milliampere. So we can say here current is going 15 milliampere, here 3. So how much current will be here? We can say this current will be 18 milliampere. They are asking this resistance. We can say this resistance becomes total voltage 4, and this resistance, okay, voltage is 4 and current is how much here? Your 18 milliampere. 18 into 10 power minus 3. This will be the your answer of series resistance only. Okay, same type of question will be coming. They have given load current. I have changed. Suppose load current not given, then we can find the load current. I wanted to take this point also, that this voltage and this voltage always same. Load current given, very good. Otherwise we can find the load current by taking this voltage also. 6 divided by 2. In the NCERT load current is given, so directly we can take the okay relate here. If not given, then here potential 6, here also 6. So we can find, because I cannot take the two questions I cannot take separately. Okay, so taken in the single question. So now coming here, then comes here, these are the some devices that you have to remember. Very simple questions are asked on this one, that we are going late by the 10 minute, but I have taken semiconductor first also, because mostly semiconductor important we ignore also. Like other chapters, if I start like unit dimension is a very long one, but almost everyone is very, very well comfortable about the dimensions. In the dimensions, what I say, nothing you have to remember. Of course, measurement, I can say few things in the measurement. So which are the more important and theoretical one that I need to explain. That's why I started with the 12th only. So we can say photodiode, and these we have to do. So we'll do this one quickly. Listen, in the photodiode, first of all, you have to remember first one, photodiode is okay, reverse bias. Okay, it is the reverse bias used to detect light. It is used for detection of light. Okay, So whenever any small intensity of the light, okay, will be coming, then it should be able to detect whether light is coming or not coming. Mainly these diodes we use in the camera as the sensor, okay, sensor, okay. So these are used. So we can say what happens that whenever these okay photons are coming, and here in this one, okay, when photon are illuminated with the okay with energy h nu greater than the energy gap, then what happens here? Electrons holes will be created, and these electrons holes will okay, and because of the movement of these electron holes, because here always the field is there, so field will okay separate, field will separate. So we can say whenever we'll get sudden change slightly change in the current in the reverse bias, why we are putting region is because under the forward bias there is the huge current is there, but in the reverse bias there is no current is almost very less. So when photon will come, they will break the bond electron hole created. So due to electron hole, some current will be generated. This current we can easily notice only under reverse bias. This one we can only notice under reverse bias. Under forward bias, so much current is there. Like here, if I say there are the crowd of 1,000 people, in the 1,000 people, if one or two people coming or going, any difference is there? No difference at all. Okay, but if there is only one or two people are there, and 2, 3, 4 more people coming or going, then there is the difference. So now we can say under reverse bias only we can sense this small change in the current. Okay, so you have to remember. Okay, someone is writing, please stop spamming comment. Sir will not notice you if he will ignore you, just like you ignore physics. If you ignore physics at this moment, then your game will be over. And of course, okay, your comment I'm not reading also, okay, because I have to cover all the important things. So whatever you are saying, I am not okay focusing on that. Okay, most of the things that we have to, because today class you are going okay. If you ignore today, means game finished. Baseball bat. That bat is not with me. Okay, that is in the car. Okay, so coming here, okay, remember this thing, reverse bias used to detect the light, and using in the reverse because a small change we can detect here, okay. So in this one, what happens that if here more intense light, more intensity coming, then more current will be more or less. Then we can say current also more, because more electron, okay, more bonds will be broken. If more bonds are broken, then what will happen? More current will be also more. Okay, so suppose less intense light of less intensity coming, less current will be there. Less current. If more intense light coming, then more current you will detect. So this is the graph that you have to remember here. Okay. Or okay, remember this line also. The magnitude of the photo current depends on the intensity of incident light. Okay, photo current is directly proportional to incident light intensity. Remember this one. And you know, in the reverse, this is the graph here. Okay, this one is the graph. So this one is at the I1 intensity. This one is here I1. At the I2, we can say I2. This is the I3. So this current is I3. So we can say current keep on increasing as intensity increasing. So we can say which intensity is more, I4 than I3, I2, means here current is less, so intensity less, here current is more, so intensity is less. Okay, yes. So this is the first graph that you have to remember here, and this photodiode is over. Okay, so in the photodiode, what is you have to remember? Only things, reverse bias, and in this one intensity directly proportional to your okay current here. One question I can take, because you know that okay, in this one energy will be coming, okay, energy will be coming, and then electron holes will be created. So they will say that one diode D1 is having okay gap of 4 electron volt, D2 is having suppose a gap of 2.5 electron volt, and D3 is having suppose 2 electron volt. These are very okay, only one famous question here in this one. So now we can write here, if you are send okay, light of incident, suppose 4000 angstrom incident. If 4000 angstrom incident, then which diode can detect the light? Means in which diode electrons will be excited, means electrons will break the bond. Okay, electrons will break the bond. Now we can say, yes, yesterday paper also this was there. Energy of this one is how much here? 3.1. So energy is 3.1. How you will calculate? Using the same formula, 12400 divided by 4000 we can calculate. So 3.1. So we can say, yes, this is having 3.1. With this energy, this will be excited, this will be excited, but 4 will not be excited, and 4 not possible. Okay, so 4 means this D1 diode will not be able to detect. Okay, D1 is not going to detect, only D2 and D3 can detect. So you have to remember this one. Next one we can say here coming LED. In the LED you have to remember, it is the doping, heavily doped, okay, under forward bias. Okay, heavily doped under forward bias. They will ask the question, LED forward bias or reverse bias. We can say LED the your okay, forward bias. In this one what happens basically, heavily doped means we have so many charge, okay, we have so many electrons and holes, means I can say this side we have, okay, so many holes. Heavily doped means strong holes, and number of electron and hole concentration is huge. Okay, so now under forward bias they are allowed to meet or not allowed to meet? They are allowed to meet. So we can say they are allowed to meet, and when they are allowed to meet, then what will happen? Yes, when they are allowed to meet, then what will happen? Means they will make the bond. Okay, they will make the bond, and when they are making the bond, then energy will be released. Energy will be released, and if this energy comes in the visible range, we will see the light. If this energy is in the your infrared, we will not see the light. We will only get the thermal radiation. Okay, so we can say in this one that equal to the band gap, they will release the energy. So electron holes recombine and releasing the energy. This only you have to remember. They will forward bias, they will move towards each other, they will recombine, releasing the energy. This line clear here. They are moving forward bias, so they will move towards each other and they will recombine, releasing the energy. Okay. If I say silicon and germanium, silicon is having your gap of 1.1, germanium is having gap of 0.7. So these two cannot be used because this energy will lie. This will fall on which zone? IR. If you calculate the wavelength for this one, this is coming in the your this will be near to your 11,000. This one if you calculate, then okay, IR, both are in the IR, so cannot be used for okay, LED. We cannot use for the LED, okay, light emitting diode. So which one use? Basically we have a special material, like we have gallium arsenide phosphide are used. Okay, gallium arsenide phosphide, some other materials also used for this one. Means here we can say that okay, wavelength will be decided by the your color. Wavelength will be decided by the color. So written here that which one we are using. Okay, that okay, here we'll read this one. For the fabrication of visible LED must have at least band gap of 1.8. More than 1.8 is needed. More than 1.8 is needed. Okay. Okay, because spectral range is basically this one, 1.3. So in this range, gap should be there in this range. Okay. So we have gallium arsenic phosphide, gallium arsenide phosphide, and for that gap is almost, we can say that is the your 1.9. Okay, then we have GAS, these are the inorganic, 1.4. okay, so we can say, and then depending on that we can use. Okay, so 1.4, 1.9 means we have to use this one. Okay, only in this range we can get the visible light, 3 eV to 1.8, but this is the visible range. Okay, why LED are good? Of course, you know the reasons, so no need to say, because okay, they are taking less power and all the things. Okay, yes. So for the LED, you have to remember, okay, this thing, whatever forward bias. And remember, in the LED one graph also you have to remember here. Okay, this is the graph. One graph is only coming like this. So because this is the forward bias, so graph will be for the forward. So we can say this is the red, this is the G, this is the B. Okay. So this color pattern you have to remember, red, green, and blue. Because here we know that wavelength will depend on the your gap. This is having, here we can say your potential will be more, knee potential more means more gap means more energy means less wavelength, okay, RGB. Okay, this graph with the RGB pattern, you remember. Then last comes solar cell. Solar cell use is basically, solar cell use is always to get the power. We are putting solar panels to get the power, so we cannot supply any external power. No external power supplied means basically no external bias applied, so unbiased. Okay, it is always unbiased. Okay, and junction area is much larger for the solar radiation to incident, because we are interested into more power. So this thing you have to remember, unbiased. First of all, it is unbiased, number one. Then we can say junction area is very large. Okay, means if I say that here in this one, this area we have to keep large, but in this region only your field is there. So what will happen, whenever your photons will come, that electron hole will be created, and this field will separate the electron hole. Hole will be accumulated this side, electrons this side. So this side minus, so much strong negative will be there. Okay, all the negative, okay, electrons will be there. And this side all the holes. So here what will be okay, so much positive charge will be there. So we can say this will act like the two terminals of the battery. Whenever electrons holes will, okay, will be there, they will move. Okay, one this side, field will separate them. So this side will get the your strong positive, this side positive. So this will act like the what? Terminals of the battery. Terminals of the battery means now we are getting the your EMF. Okay, so they will ask first question, EMF produced depends on, we can say EMF produced depends on this concentration of positive and negative, and this positive and negative depends on the your electron and holes number, and this electron and holes number depends on the your number of photon. More photon coming, if more photon coming, then what will happen, more electron will break, and if more electron breaking, then this side more positive, this side more negative, so more EMF will be there. So EMF actually depends on the, okay, intensity of the light. So remember, EMF depends on the intensity. Okay, so these are the things to remember in the solar cell. If you applied nothing, then we are going to get that here maximum potential is there. Okay, so we can say right now circuit is open and this voltage maximum. So this is known as your open circuit voltage. Okay, open circuit voltage, because circuit is open right now, or not connected anything. It is acting like the your two terminals of the battery is acting like the battery here, nothing connected. Open circuit voltage, that is the maximum voltage here. If I connect one wire, if I'm connecting one wire, okay, from this terminal and this terminal, if one wire is connected, now this becomes short circuit, and short circuit means there is a maximum current in the circuit. So we can say current becomes maximum when you connect, okay, and we are getting this characteristic this way. So here we can write this is known as short circuit, okay, short circuit current. Okay, so this graph you have to remember for the solar, okay, open circuit voltage and short circuit current. Yes. Okay, it is unbiased, junction area large, and EMF is, okay, EMF, okay, depends on the intensity. Okay, EMF depends on the intensity, so that is written here. And yes, listen here, one more thing is written here. Lot of people, okay, have this doubt. Note that sunlight is not always required for the solar cell. We think that whenever okay, sunlight is there, then only we can get the your this operational. No, note that sunlight is not always needed for the solar cell. Any light with photon energies greater than the band gap will do. Okay, any light. Okay, okay, if more than band gap, that can also do the work. Solar cells, okay, are used to power the electronics devices, satellite and space vehicles, and also this thing means all the time basically sunlight is not needed. Any light can do the things. Okay, this graph we can skip. Transistor also we can skip here, means it is not there part of the syllabus now, but this was the old NCERT. So we have finally here logic gates. Okay, and in the logic gate quickly we'll go, because sometime we have reserved for the logic gate also, because nuclei will take very less time. Nuclei means will be done in the maximum 15 minutes. Atom will be done easily. Photoelectric effect will take some time. So next we are targeting that in 1 hour we will complete those things also, and then we'll have the break. After that we'll be having the break. Okay, Yes. So listen. So in the logic gate, basically we have only two signals. Binary number has only two digit. Okay. Binary number has only two digit, 0 and 1. Okay. 0 means we can say 0 volt. 1 we can say 5 volt. 0 means low. 1 we can say high. 1 we can say high. Okay. 1 is the high and 0 is the low. Yes. So only two are there, 0 and 1. Okay. Now in this one, some gates are there. 0 you can say like okay, 0 we can say off and 1 we can say okay on. Okay, when the light is on, output value is 1. When the light is off, output value is 0. Okay, so to represent high we can use the 1. To represent on we can represent the 1. Okay, to represent a good thing we can represent the 1 like this. Okay, so this is the analog signal, but this is the digital one. Digital can only take the two values, either 1 or 0. So we have here some logic gates. Okay, first logic gate is the NOT gate. Everyone how to remember, this is your representation of the NOT gate. And how NOT gate basically this one. This part is important. Okay, this triangle plus this circle will be there, and 0 becomes 1, 1 becomes 0. This is inverting. That's why used. Okay. That's why it is also known as inverter gate, also known as inverter. Okay, also known as inverter gate is written here. That's why this is also known as inverter. Okay, now then comes OR gate. First you have to remember, then we'll do the question. OR gate. If I say OR gate, then this is the representation of the OR gate like this. And in the OR gate is known as summation gate also. Summation gate also means basically we can say Y is actually your A plus B like this. So 0 plus 0 becomes 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. Okay. Here no value is more than 1. Okay. No value will be more than 1. Okay. Now next thing we can write here. Okay. That is, okay. This is the one question. Justify the output waveform for the OR gate. Okay, so you can say this one is the input given here and this is the your output given. For these questions, how you will solve? You will always make the truth table so that mistakes not there. So we can say this is the your A, this is the B, and here I will write my output Y. So we will start between T1, T2. You can say this one is 1, 1, 0, 0, 1. Like this you can write the values. Okay, 1 means high and low means 0. So we can say 1A is basically 1, then 1, then 0, then 0. To solve question, you need maximum 4. You will get the answer always. Okay, if you have taken the 4, only 4 you can take. Okay, yes. Okay, only 4 we can take. Things will be done. For the B, we can write here. This is the your 0, 1, 1. Okay. 0. So we can write B, it becomes here 0, 1, 1, 0. Make the truth table. Now because they are asking for the OR gate, they can ask for the OR and anything. So 1 plus 0 becomes 1, 1 plus 1 becomes 1, 0 plus 1 becomes what? 1, 0, 0 becomes 0. And we can say in the options we have to see, okay, all the options will be given. So we can say this is the 1, 1, 1 and this is the 0. And we got the same answer, 1, 1, 1, 0. You can see here 1, 1, 1, 0. Okay, so you can easily match. Over. Finished. Yes. Next one is coming. These questions are given in all gates actually. AND gate. AND gate is known as multiplication also. Okay. AND is known as multiplication gate. Generally, you are having only two. Okay, two inputs. If they are giving you multi-input like this also, A, B, C. If they are given like this also A, B, C, then we can say this is the your A, B, C. You will identify like this. This D is given, and then we can say this is the A, B, C multi input also. This is like the product. So we can say 0.0 is 0 here. 0 multiplied by 1 becomes 0. 1.0 is 0, and 1.1 remain as 1. 1.1 remain as 1. Okay. So this is the multiplication, or we can say this is the your product gate. And if multi input also given, then we can say A, B, C multi input becomes here A, B, C. Okay. Now. Next one we can say here, this is the same question given here, that question was same. Okay, so here we know, can you solve this one? Exactly same question, only because answer is written there. Okay, yes. Then comes NAND gate. Okay, NAND is basically what I can write here. NAND is nothing but the not of AND. Okay, NAND is not of AND. So in the AND gate, if anywhere this is the AND, and when I will put this NOT gate, this becomes the your okay NAND gate, means A dot B. A dot B, okay. Of course, we'll do the conversion, okay. A dot B, if you put the bar, because not means bar. So this is the basically your which gate? This is the which gate? This is the your NAND gate, okay. Now you have to know the De Morgan here. What De Morgan is saying basically, De Morgan says the dot you can convert into plus and plus you can convert into dot. Big line you have to convert into a small line into big line depending on your requirement. Means change the line, change the sign, change the line, change the sign. Big line, make it small, but at the same time you have to change the sign also. A small line make it big, but at the same time you have to change the sign also, okay. Yes, change the sign, change the line, okay. Change sign, change line, okay. I will explain this De Morgan separately because De Morgan we use multiple times here. So, okay, listen. So we got for the De Morgan here. So whenever you get like this, A plus B, suppose we got like this, then you can say this is the big line. Big line I can make it a small line also. But at the same time, you have to change the sign also. So we can say this becomes your A bar dot B bar, okay, A dot bar B bar. If I say you are having A dot B big line, then what we can here basically your A bar dot B bar, okay. Big line becomes basically what? A small line. Whenever you're making the big line into a small line, then remember dot means this is the dot and this dot will become what? Plus, okay. So we can say whenever you are changing the sign, you have to change the line also, okay. So big line, okay, becomes your small line. Yes, 1 hour 30 minutes completed. That is okay. Constantly going in my mind because in the 5 hour we have to do all the important things. Okay, going somewhat detail also. Yes, but I know some chapters will take time. Will take lesser time. Some chapter takes more time, so time can be managed easily. Okay, 1 hour 30 minutes completed. Still we have 4 hour 30. Means 4 hour we can say yes. So we can say big line. Okay, becomes a small line, but at the same time plus will become dot. Here also big line becomes your small line, but dot becomes plus. You have to remember this thing, okay. Yes. So now this is the your De Morgan thing here. So we'll use this one for the convergence. Again going for this one. So you have to remember NAND is basically nothing but the not of and then same, okay. Practice these type of questions like this one is there again coming. So I will solve, okay, this question here for you. So we can say again, I will make the truth table A, this is the B, okay, and this one I will write the your and here then I will write the NAND, okay. So let's do it. So A I can write basically here I can go 0 0 1 1, only 4 needed max to max, okay. So 0 0 1 1. B I will write here B is 0 1 0 1. So B I can write 0 1 0 1. Now we'll go for the and will be 0 dot 0 is 0, 0 multiply by 1, 0, 1 0 0 1 1 1. You have to plot for the NAND, not the AND. NAND means, okay, opposite of AND, inversion of AND. So we can say this becomes 1 1 1 and 0, and you can say yes, answer is having your 1 1 1 and 0. Can we solve like this here? This thing can we do? Okay, so this is the NAND. Same way coming your NOR also, okay. So now we will see your NOR. NOR is basically OR gate plus NOT gate, okay, or inversion of OR, opposite of, okay, or negative of or inversion of OR, okay. So we can say yes, so we can say here in this one, if I write your OR gate everyone knows, okay. If I write OR, okay, OR, then you know 0 and 0 is what? 0, okay. 0 1 will be what? 1, 1 0 will be 1 and 1 1 will be what? 1. But we know in this one that we have to inversion means 0 becomes 1, 1 becomes 0, 0 like this, okay. So you have to remember the truth table with the help of OR, okay. Yes, can you remember the truth table first of all? Truth table of everyone's, okay, everything should be remembered, and then those high low questions, high low, okay, those, okay, series based questions you have to, okay, no. I will take all the questions also for the NCRT in the logic gate, okay. Now what are the integrated circuit? Integrated circuit means so many circuits combined. IC, IC, okay, IC means your integrated circuits. So many circuits combined are known as your integrated circuits, okay. But okay, this is still going on, okay. We have LSI, VSI, so we don't have to get into the detail of this one, okay. SSI, there's a very small scale integration. There was the less than 10, it was used very long back, now we are not using. And then MSI, less than 100, now not used. LSI, and mostly we are working on this technology VLSI, okay. And now we have gone to the okay, nano level also. But explain this topic, no need, okay. IC, just you remember, integrated circuit means okay, so many circuits are there, that's it, okay. You have to keep in the mind, okay. This is the means one okay, future of computer technology, all the things we can escape. So now before going to the your questions, because questions we have to solve all, I will say some important things in the logic gate, like De Morgan told. Remember, single input or sorted input or both input same, same, okay. Single input, sorted input, both inputs same, okay. Both inputs same, okay. Then NAND and NOR, okay, behave like NOT. They behave like NOT, okay. Single input, sorted input, both inputs same. NAND and NOR behave like NOT. If I say like this, okay, suppose you got this circuit. If this is the A, this result will give you A bar, okay. If I say same circuit here, if okay, both inputs are like this, this is also A, this is also A, then answer of this will be also what? A bar. You can prove also, because A dot A, okay, A bar. And if you have like this, both inputs are sorted also, then also we can say for this also answer is going to be what here? A bar. So remember, if both inputs are same or both inputs are sorted, then they behave like NOT. Okay, means using these NAND and NOR we can make any gate, okay. These are known as universal gate. We can construct any gate from here, okay. So now we can write here this one. You can say like this is there, same here we can say A, this becomes your A bar, or we can say like okay, next one is here, both are same, A. If both inputs are same, then that will be the NOT. Or we can say both inputs are sorted like this, then also we can say NOT gate. Remember this point, okay? These are the NOT gate always, okay? Single input, sorted input, both inputs same. This point is used multiple times in the examination, okay? They are the behaving like NOT. They behave like the NOT, okay? Now, I will go to the next page here. Remember that if you need a NAND to NOT, how many gates needed? Only one gate needed, okay? Only one needed. NAND to AND. How many NAND required? Two NAND required. How many NAND required? Two NAND needed, okay? If I say NAND to OR, how many needed? Then we can say three NAND needed. Theoretically, they will ask you how to remember, okay? Three needed. And if they are saying NAND to NOR, how many needed? We can say in that case your four needed, okay? Four needed, okay? Reverse also I can write NOR to NOT. How many needed? We can say one NAND needed, only single input. NOR to okay, OR. Then we can see here two means not the NAND, okay? NOR. Two NOR needed. NOR to AND. So we can say NOR to AND, basically here three NOR needed. And then we can say NOR to NAND. So we can say NOR to NAND. How many needed? Basically here four NOR needed. You have to mug up this thing. Explanation I cannot give for all as of now, okay? So mug up all the things, okay? We have to be very effective in these, okay? These 5 hours must be equivalent to almost 90-100 questions. Means 90-100 marks. It will be, okay? Surely, because all the important things writing here, okay? So this one you have to mug up. Next point that I have to say here in the exclusive OR, XOR, okay? Exclusive OR or XOR, okay? XOR. What the XOR, you have to remember that exclusive means, like suppose if I have, okay, suppose you have two car, okay, one is the, suppose your black car, one is the white car, okay, you have two cars, black car and white car. Will you use both car at the same time? Will you use both car at the same time? No, you will use one car at one time, okay. Means one day you are going by the white, other day means not going by black. If you are going by the black, you are not going by the white. So like this you can remember, okay. Or suppose I have to gift you two car. If I have to gift you two car, you will take the same model, same make, same color, everything same. If I have to, I said that if you you are okay going to get and then you will get two car. So both car, will you accept? AIR1, okay, you will get the two cars. Will you accept same model, same make, everything exactly same? No, you will not take. You will take different model, different colors, okay. So that when you are going to your medical college, okay, in the college, one day you are going by the black, one day you are going by the your okay, white, like this. I'm saying that assume, okay. So yes, if you get okay, you can get also. If you get AIR1, you can get also. So we can say here in this one that we want exclusive things. But if I give you both same, then you will not be happy. Even though you are getting the car, you are getting two car, okay, but you may not be happy if I'm giving both exactly same. You will be only happy if okay, if I'm giving different, then only you are going to be happy. So same. Are you happy? Same. Same means you will not get the feeling of high. Feeling of high only comes when different is there. Feeling of high will come when things are different, okay. So using this, you have to remember the truth table. I can say that if A, B, and this is the your I can say output here. I can say output as the Y, because in NCERT everywhere written Y. So same is there. Like I can say 0, 0, 0, 1, okay, 1, 0 and 1, 1. Same will not give you feeling of high. Feeling of high will come whenever it is different, okay. Feeling of high means it is different. So we can say 0, 0, output will remain as 0. 0, 1, different. Yes, now you are high, so it will be 1. 1, 0, it will be high, okay. And 1, 1, it is going to be 0. Can you remember like this truth table? Same, no, okay. But different will give you high, okay. Different will keep you at the high level, okay. So this table remembered, then you remember your expression. Why you will remember? If I am using A, I am not using B. A, B, bar. If I am using A, not using B. Plus means or, okay. What are the other option? If I am using A, I am not using B. Or I am not using A, I am using B. So this is the your okay. You remember like this. I am using A, not using B, or I am using your A. Means I am using B, not using A. Can we remember this thing also? So this is the expression AB bar plus A bar B. These are the only two things needed here. Two things needed in the XOR exclusive OR. Okay, AB bar plus A bar B. Or we can say diagram of this one. This is the A coming here. This one is the your B. So we can say I can take the bar because bar is needed here. Okay. So we can say first how to multiply A and B bar. This becomes here A bar. This becomes here your B bar. So we can say multiplication of A and B bar. From here I will take the A and then I will take signal like this and then I will multiply. Multiply means AND gate. So this give you here A coming. So this gives you A, B bar. And now we can say from here A bar coming. From here I will take the B. Okay, like this. Okay. So we can say like this and then from here I can multiply B coming from here. So we can say this one. So this becomes here A bar B. And then you have to add both. And for the summation, we add only this. Okay. OR gate. This is your diagram. Can you remember the diagram like this? Okay. Yes. Okay. Some people are coming for the fun in the class, because I have posted message on Instagram also, on WhatsApp also, that join me live. Okay, so some are coming for the fun. Let them have fun. Okay, they are coming for the class. Of course, they are not coming for that. Why you are taking them serious? Okay, enjoy. Like I'm chilling, you can also chill. Don't fight in your comments. Okay, focus on this one. This XOR coming, we have to do this one. AB bar plus A bar B. Okay, They are taking your name, no problem, okay. Some people, okay, how has already accepted that my game is over, okay. Let them do whatever they want to do. Okay? If you ignore, automatically they will leave. They are just coming for the attention. Don't give the attention. Someone is coming for the attention. Don't give the attention. Okay, they will not stay in the, okay. Oh, this is array. This is not. Means this is the OR gate. Okay, not the. Okay, so we can say this becomes here A bar B plus it becomes A B bar. Okay, remember this thing. I'm also okay, slightly distracted because of this, but okay, don't focus on that. Okay. Don't focus on that. So this one you have to remember first of all that okay, different gives you high, and here I'm using A, not using B, or I'm using B, not using A, and then okay, this diagram not okay, you don't have to mug up. You will be able to solve whenever a question coming. You can easily solve this thing. Okay. So these are the things that I have to say in the logic gate. Then okay, we can quickly go for the questions of the logic gate. Here, see here, and these are the questions, because you have practiced very good. If you are not practiced, you can just okay, see here fast. Okay, these are the questions given, or you can, okay, I will say you can practice, okay, these questions, because all are the important here. This gate is, this is the basically what, or plus not plus not. So we can say this not cancel. This, okay. So answer is what? Or. Okay, answer is or. Here we can say this is the A, this is the A bar, this is the B, so this is the B bar, and here you will write A bar plus B bar. Then we can, okay, A bar plus B bar, and then there is a circle also. So we can say this becomes what? A whole bar. So now we can say that okay, plus becomes a dot like this. A small bar as it is, that big bar also becomes a small bar. So answer becomes what here? A dot B. A dot B. Okay, clear? Now this one is the single input. Single input means this gate is basically which gun? This gate is your not. Single input is always not. Single input is always not. Okay. So these are the some of the questions like this. Okay, here also we can say this one also we can solve easily. This one is basically what? And plus not, because NAND, and this is also what? This itself is your what? Not cancelled. So answer will be left only and, only and is left. Here we can write this is the A, so this will be what? A bar. This is the B, so this is what? B bar. And what we can write here in this one, your A bar dot B bar and whole bar. Dot becomes plus A plus B, and then we can say like this, small bar as it is, big bar becomes a small, so answer becomes finally what? A plus B. Can we do these questions? Yes. Okay. Finished. Okay, because these are given me, these type of questions only they are asking also exactly as it is, slightly changes, they don't go okay beyond the NCERT too much. Like this is the, again same question coming. You can say this one is the or plus not, and this is the what? Not cancelled, and then we can figure out the things. Okay, and this is also the same one. Okay, yes, we can do all. So now this is you're over. Semiconductor is finished here with the logic gate. Semiconductor over. Okay, one very large chapter is finished here. Now we are free to do next one. Yes. Okay, so one finished. This is the your three questions. Hopefully, all three questions you will be able to do. Okay, all three. Okay. So now we'll be having a quickly okay break for 5 minutes. 5 minute break. Yes, 5 minute break is needed because I'm also full. Semiconductor over. Now we'll go for the nuclei. Will not take time. Nuclei, a lot of things are deleted also. So then we'll do the nuclei. Next 1 hour nuclei and whole modern will be over in the next. Yes. So we'll start exactly 5 minutes. Okay. I will take some water. 5 minutes. Okay, so 5-minute break is over now here. So we'll take the next break after completing full modern physics. Break is over. Next break we'll take for the 10-minute. Okay. Yes. After completing full modern as well as optics. So whole 12th class will be over. Okay. So now we are going for the nuclei because nuclei now is somewhat a small chapter. A lot of things they have deleted from the nuclei, means whole radioactive part is deleted. So we don't have much things. So when things are less, from there what things they can ask. Okay, very focused things are there in this one. So one question okay will be there. Earlier they are used to be 2 questions. So one question, make sure we can do. I'm confident that you got everything in the your semiconductor plus logic gate. You are feeling that yes, I can do everything without any load. We have to do. Okay, of course today exam is also not there. So if you have to go beyond 12:30 also, we can go. Target is 12:30. We can go up to 1:15 also if needed. Okay. Only thing that we have to get the confidence. Yes, whatever topic is done, we have done perfectly. You are writing the short notes also, and then okay. Because at the last, okay, last lab that we take when we are making the we are doing anything at the last, we go with the very precision. Okay, papers you have to make at the last moment when we are doing the work, so precision is increased. Okay, so now in the nuclei, basically first of all that you have to remember here that okay, we are going to express everything in the AMU. Okay, everything in the AMU. What are the AMU? Basically it is defined as 1/12th of the mass of the C12. Okay, 1 AMU is the 1/12th of the C12. That's it. Okay, and its value, if you okay, already you know, 1.66 into 10 power minus 27. Okay, that you have to remember here. Now isotope, isobar also this time they have deleted, so I'm not going for that point also. Okay, now you have to remember here in the discovery of neutron, what are the point needed, what is the important point. We have asked so many times or okay, question also on this one in the discovery of okay neutron. This okay line is important. A free neutron like a free proton is unstable. Remember this line. A free neutron unlike a free proton is unstable. It decays into a proton, an electron, and antineutrino. Okay, means neutron unstable. Here I will say one thing in this one. Okay, this paragraph, what are the meaning of this thing? A free neutron is unstable. If I say inside nuclei, okay, I will take the okay one page for this one so that you can okay write here. Inside nuclei, if I write, this is the nuclei. Okay, so inside nuclei, proton can convert into neutron. Okay, so we can say 0 means here okay 1p1 converts into 0 and 1. This reaction must be there in your mind. Okay, you have to keep here. Yes. So 1p1 okay 0 and 1 plus we can write here in this one, if you balance okay the reaction, then what happens here? Plus 1 E0 okay, plus 1 E0 okay, and the same time we can write here in this one neutron 0 and 1 converts into proton 1p1, and here we can write basically minus 1 okay E0. This one is known as beta electron. Okay, beta electron. Along with this one we are getting one more, that is known as your neutrino. Okay, along with this we are getting the your means this is the antineutrino, and that is the this is known as your neutrino. Okay, neutrino, antineutrino detail not needed. Okay, they are just particles, some particles. Okay, this one is known as your beta positron. Okay, so this is the beta positron, this is the beta electron. Inside nuclei both reactions are possible. Proton can convert into neutron, neutron can convert into proton. They are doing this conversion for the electron proton balancing, but for the stable nuclei one optimum level of neutron protons ratio is needed. So inside both possible, but outside, if I say outside means basically you're free. Okay, when they are free, not the okay inside nuclei. So neutron easily converts into proton, 0 and 1 converts into 1p1, because mass of neutron means we can say mass of neutron is more than mass of proton. Okay, remember this slide. Why it can convert, why it is unstable? Because it can easily come from higher mass to lower mass. Coming from higher mass to lower mass is much easily because it have to release some energy. It can release energy means it can reduce its mass by releasing some energy. Okay, so possible. Okay, but if I say 1p1, okay, 1p1 conversion into your 0 and 1 is not possible. Not possible means free proton always stable. Okay, stable reason being because proton have to go from lower mass to higher mass. Okay, and lower mass to higher mass means it need to absorb some energy. No one is going to give this energy to the proton. So 1p1 to 0 and 1 not possible. It is stable. Can you remember here? Yes. Okay, so this thing you have to remember, that is that paragraph written. Lot of time questions are asked from here. Okay, so inside nuclei both possible, outside only neutron to proton possible. Proton cannot convert into neutron. Very simple line written here. You have to remember. Okay, now going for the next point here. So next thing is coming about your binding energy. Okay, so we can say before the binding energy, this time I am expecting question from the radius, because a lot of time this binding energy they have asked. Radius is a very simple thing, like this one is there, that radius is basically this relation that is written. I'm writing somewhat big here, r naught a power 1 by 3. Okay, radius r naught a power 1 by 3. So they will give you here that some okay, r naught is the 1.2 into 10 power minus 15. They can say a is 125, a 125. Okay, and for that you have to question like this. A suppose 125, you have to find the radius. So you say r equal to becomes here r naught, that is the 1.2 into 10 power minus 15. 125 power 1 by 3 becomes 5. So we can say this becomes your 6 into 10 power minus 5. Coming from here, we can say R1 by R2 will be equal to basically here A1 by A2 power 1 by. Will say that A1 equal to I can take 64, A2 I can take 27, and then they will ask if they are giving 26 also, you will take the approximate, okay, approximate answers, and we can find the ratio of the radius. Okay, if they have given this one, sometimes they will ask ratio of the volume. So we can ratio of the volume they are asking, then we can write R1 by R2, okay, whole cube. Okay, that also we can do. So volume ratio also we can find. Volume is different, but density for all remains same. Density is same. Density independent of the mass number. Density order is 10 power 17. Density remains same for all. Okay, so you have to remember that density remains same. So these are the 2-3 questions on the your okay, radius. You have to remember density of the nucleus is constant. This line, okay, density of the nucleus is constant independent of A. For all nuclei, different nuclei are like drop of constant density. Okay, so this line, different nuclei are like drops of constant density. They ask your nuclei can be explained by which model? We can say nuclei can be explained by liquid drop model. Okay, nuclei can be explained by your liquid drop model. Okay, liquid drop model, because we can assume different nuclei are like drop of liquid of constant density, can be explained by okay your okay liquid drop model. Now this is one okay question coming. Of course nuclear density is asking, so we can do. Okay, then comes mass energy relation. Always remember that for the mass energy relation only we have two formula. E is basically equal to mc square, where m is the basically we can say mass. Okay, or we can write sometimes, or we can write delta m into c square, where this becomes mass defect, or we can write okay E equal to, but here m will be in the kg and this energy will be in the okay joules, or we can write delta m into 931.5. okay, here energy will be in the mega electron volt and this delta m will be in mu. Okay, either question will be from the radius, either question will be from this formula. Okay, in the nuclei only okay, this is a formula delta mc square, or we can say delta m into 931.5. okay, delta m into 931.5. here in this this is in the AMU and mega electron volt, or mc square means delta m is in the kg, delta m in the kg, and that energy will be in the joule. Okay, so first question coming, very simple, very important, nothing is there. Energy equivalent of 1 gram of substance, we can say energy equivalent of 1 gram. 1 gram we have to take in the kg, so we can say energy will be equal to 10 power minus 3 into c square, 9 into 10 power 16. All got the answer here, becomes how much? Your 9 into 10 power 13, okay, joule over. Yes, yes, it is the finished. Okay, very simple question. We can easily do this. Okay, they can say in place of 1 gram, 1 milligram, 1 nanogram. This changes can happen. Okay, 1 gram, 2 gram, 5 gram. But this is the one simple question. Okay. Next question, okay, nuclear binding energy. Okay, binding energy means whenever neutron and protons are combining, neutron and proton. Okay, if you keep the neutron, okay, separate, they are not stable. They convert into protons. So neutron and proton will come together to make the nuclei, stable nuclei. Whenever they are coming together, then they release some energy. They release some energy and then make your stable nuclei. This release energy is basically known as your binding energy. Like if you say we have to calculate binding energy of the oxygen. Okay, this is the example given. So you can say oxygen is basically having 8 neutrons and 8 protons. Okay, 8 neutron and 8 protons. So basically we can write okay, proton and neutron mass. Whenever it is coming, then we can always take mass of the proton. Okay, this is written here. This is the formula. Okay, mass defect, that Z into mass of proton, because proton number will be always equal to Z. Neutron number will be the A minus Z into mass of neutron minus mass of the nuclei. After that, we can multiply with the 931.5. Like okay, this is the one question here written, that find the energy equivalent of 1 atomic mass unit, first in joule and then in the mega electron volt. Okay, so we have to find the mass defect. Here mass defect is coming this. Okay, this mass defect is calculated in the example. How you will calculate this mass defect? Mass defect you will calculate, because mass defect will write here 8 times of mass of proton plus 8 mass of neutron minus mass of okay, mass of oxygen. These values will be given, proton, neutron, everything value will be given. You have to just put and you will, okay, you will calculate like this. So 8 mass of proton plus 8 mass of neutron. This value is coming like this when we are solving 0.13. In this one, we'll multiply with the 931.5. When you are multiplying with the 931.5, we are getting the answer. Okay, so all the time mass defect we can find. First of all, after getting the mass defect, we can multiply with the 931.5. Okay, generally they will use this MEV only. Okay, means energy should be in the mega electron volts. You have to multiply with the your 931.5. okay, now this energy that is we have calculated here 127.5. 127.5 MeV is basically, okay, for how many nucleons? Total 16 nucleon, total 16 proton plus neutrons are releasing. So sometimes they can ask per nucleon, how much energy per nucleon? This much energy, 127.5 is energy used by all. Energy released by all means all 16. They will not ask energy released by all, total energy released. They will ask energy released per nucleon. If they are asking per nucleon, we can say 16 releasing this much per nucleon means by 16. So this is the your binding energy per nucleon. Okay, binding energy per nucleon, which you will divide with the 16. You got the binding energy per nucleon. Here they can ask question either for the oxygen, either for the carbon, and either for the helium. Okay, these are the most probable question. Binding energy of the helium, binding energy of the carbon already in the notes, oxygen here in the NCERT, helium we have asked multiple times. Okay, can we do this question? Mass defect you have to find, and then we can okay, get the things. Okay, this is the definition of binding energy. When they are coming closer, then okay, they have to release the energy. This energy is basically, okay, known as your binding energy. Okay, then binding energy per nucleon. This is the definition. Okay, binding energy per nucleon is basically total binding energy by your number of nucleons. We can divide. So binding energy per nucleon. This is the graph. Everyone have to remember, and all the points. Listen. In this graph, if you see here, okay, that okay. binding energy per nucleon here increasing, it is increasing. You can say binding energy per nucleon is increasing, and then after this it is coming down. Okay, down. But if you see here zone, in this zone this graph is almost linear. First of all, peak we are getting for the iron. You have to remember that peak we are getting for the iron. So iron is the most stable. But this zone 30 to 170 graph is almost linear. Means 30 to 170 are the most stable. In this one, binding energy, change in the binding energy is very less. So written, the binding energy per nucleon is practically constant, practically independent of the atomic number for 30 to 170. 30 to 170 almost constant. 30 to 170 binding energy is almost constant because this graph is almost linear, almost constant. This is the first point. Can you remember this thing? First point, that 30 to 170 are the all very constant. For them it is almost independent. Okay, and is having maximum for the iron 8.75. 8.75 maximum. Okay, maximum. Okay, then we can say binding energy is lower for both. This side also lower, we can say this side also less, and this side also less. So both side less. Okay, here also less, here also less. So then binding energy is lower for both light nuclei as well as heavier nuclei. Okay, yes. So these 2 points you have to remember. Okay, that 30 to 170 most stable, and this side they are here less binding energy, this side more binding energy, less binding energy. So they will combine, because everyone want to come to this zone 30 to 170. 30 to 170 most stable, so they will combine, they will fuse. So this side fusion will happen, they will try to combine so that they can come to this zone of 30 to 170, and this side they will divide so that they can come to this zone of 30 to 170. So they will be having the fission. So two types of process are there, one is the fusion and one is the fission. But this side binding energy less, this side also less, everyone want to come to this zone of 30 to 170, which is the most stable zone. Okay, so this graph you have to remember. Okay, then comes here your nuclear forces, because nuclei will be having the fusion, bigger will be having the division, so that they can divide and come to the zone of 30 to 170. Okay, a smaller will combine so that they can also come to that zone or very close to that zone. Okay, now so remember here that in this one, okay, and remember this thing also, average binding energy almost 8. Okay, maximum is 8.75, average is 8. Remember both the data. Okay, average is 8, maximum is 8.75. Okay, now about the nuclear force, you have to remember these points. Nuclear forces are much stronger. Okay, this first point, much stronger than the Coulomb force. Single line, this one you will remember. Okay, first thing. Okay, yes, they are short range force. Nuclear force between two nucleon fall rapidly to zero as their distance is more than few femtometer, means short range. Okay, stronger. Number point one, stronger. Okay, number 2 point, short range. Number 2 point is the short range. Number 3 point you have to remember, charge independent. Charge independent. These are the 3 point everyone have to remember about the nuclear forces, at least bare minimum. Number 1 is strongest. Okay, number 2, short range. They don't act for the large range, very large range they will not act. Okay, they are having short range. Charge independent. Charge independent means nuclear force between the proton, nuclear force between the proton, neutron, and nuclear force between the neutron is always same. Okay, this point you remember, this is a direct question, that between the proton, neutron, and neutron always going to be same. So charge independent. Okay, can we remember these 3 points? Bare minimum 3 points needed for the nuclear force. Yes, and it will be equal. Proton, neutron, and neutron going to be exactly same. Yes. So in the nuclei till now, I have told you, okay, three things in the graph. Okay, 3 things in this nuclear force. 1 thing, how to calculate the binding energy. Okay, 2 formula in the binding energy, and 1 radius things. 1 was your radius. Okay, so nuclear force will remain always same. Okay, now radioactivity we know that is not there in the but still this part you will do. Okay, Alpha decay when helium is there, beta decay, already I have told you when neutron proton conversion takes place, then beta, okay, then it is the beta, and gamma when it is coming from high energy level to low energy level. That's it, okay. Alpha in which 2He4 is there, beta in which electron or positron, that I have, okay, written na, that proton converts into neutron, neutron converts into proton, that one, okay. And gamma when nuclei is coming from higher energy level to the lower energy level, higher energy level to the lower energy level, then we are getting the your gamma decay. Only 3 types of decay you have to remember, okay, because they have deleted the radioactivity, but this thing is needed, general knowledge, okay. You have to remember alpha, beta, gamma decay. So I am now, okay, going for the next, your reactor part. But once upon a time, this half-life was very, very important, but now, okay, we can skip this one. So in the alpha, beta decay, you have to remember the basic, okay, whatever told to you, what are the, okay. Now, coming here, your this fusion and fission, okay. So listen, first of all, you have to remember this line that, okay, this thing is written one comparison, that which is why why we prefer the nuclear reactions. For the same quantity of matter, nuclear sources produce 1,000,000 times more energy than the chemical source. For example, fission of 1 kg of uranium, okay, generates 10 power 14 joule of energy. But if you take 1 kg of coal, that is only giving you how much? 10 power 7. So this is the 1 kg uranium and 1 kg coal. Almost energy is 10 power 7 times. 1,000,000 times energy is there. 1,000,000 times energy is there. 1,000,000 times. Alpha, beta, gamma, only you have to remember your theoretical thing. Because whole radioactivity they have deleted, so only theoretical. What is the alpha, what is the beta, what is the gamma? That is only needed. Okay. So this is the first point why we take the your okay, nuclear sources. Then in the fission, basically what is happening that okay, example, uranium, okay, bombarded with the neutron breaks into 2. And listen, uranium is converting to barium krypton, not fixed. Other reactions possible, like here we are doing SB and B, okay. Some others also possible, xenon and strontium also. Here in this one 3 neutrons, here 4 neutrons, here 2 neutrons. On an average 2.5. On an average, how much? 2.5. On an average, 2.5. 2.5, okay. Anish Arya, sir, what about the net force? Net force was written there, but I didn't send, because when I say the net force, people are getting confused. Net force, no one asking. They are asking always nuclear forces. That's why I have not told the net force. Net force was written, I skipped. Okay. Intensely I skipped, because when I'm saying the both, they get confused. Okay. So only told about the nuclear force, because nuclear is asked. Okay. Why I will confuse with this, all the things. Okay. Very limited things, whatever is okay important. So remember here that these products are not fixed, they can change, and always 3 neutrons also not there. Average number of neutrons are basically your 2.5. okay. Reaction, this energy also not fixed. Okay. So first of all, what happens? This entry energy, whatever the energy is there, energy first appears as the kinetic energy of the fragment, because okay, somewhere people don't don't have full clarity that how this energy is used. First of all, whenever this energy is released, this energy is in form of kinetic energy. Okay, so first this energy, okay, appears as the kinetic energy of the fragment and a neutron. Eventually it is transferred to the surrounding matter, appearing as a heat. Okay, appearing as heat. First of all, it is only in the form of kinetic energy. Then they will make the collisions. So whenever collision happens, then what happens? Heat is produced. But initially it is only in form of kinetic energy. Okay. Now, in the nuclear reactor, basically, okay, you have to remember, average 2.5 neutrons are released per fission of uranium. Average 2.5 are released. Okay. This one was the read, but now no read. Okay. Earlier it was the read, but now no read. Okay. This is our nuclear program, how it was done. So now here, remember this thing. I will say quickly here. It is known experimentally that slow neutrons slow neutrons or thermal neutrons are much more likely to cause fission. Means which one are used, slow neutrons or fast neutron? Slow neutrons are used than the fast neutrons. Okay. Also, fast neutrons liberated in the fission would escape instead of causing the another fission reaction. If neutrons are faster, they will not stay in the reactor, they will go out of the reactor. So only slow are used. Okay, slow are used. Okay, average energy of neutron produced in the fission is how much? Around 2 mega electron volt. These neutron, unless slowed down, will escape from the reactor, they will go out of the reactor without interacting with the uranium. Means they will not be useful for us, so we need to slow down. Okay, unless a very large amount of material is used for the, okay, this one. So what one needs to do is slow down the fast neutron. How we can slow down the fast neutron? This is the direct one question here. If they have how to ask, very good question. Slow down the fast neutron by elastic scattering. This one, okay, by elastic scattering with light nuclei. Elastic scattering with the light nuclei. In fact, Chadwick experiment is there. We don't have to go into detail. That an elastic collision with the hydrogen, the neutron almost comes to rest and proton carries away the energy. In the collision also you might have seen the very simple process that with the lighter nuclei if we are doing, then what happens basically? So we can slow down with the okay, elastic scattering with the lighter nuclei. Means lighter nuclei we have to use here. Okay. And for this purpose, what we are using? For this purpose, we are using water, heavy water, and graphite. Okay, these are used as moderator. What these moderator are doing? They are basically taking the energy of the neutron, making them slow, so that they can take part in the reaction. Okay, highly energetic cannot take in part in the reaction. They can, okay, escape out of the, your reactor. So we can use water and heavy water. And then this is the, I'm skipping this part here. You can directly go controller rods. So which are the controller rods? Basically, controller rods are made of neutron absorbing materials such as cadmium, boron and cadmium. Okay, boron and cadmium you use as the controller will absorb number of neutrons, so that we can always. Should we remember the nuclear reaction? No, not need. Okay, no need. So controller, you have to remember that boron and cadmium are used as neutron, okay, absorbing. Okay, means they will control. Okay, so which one is better here? Okay, which one is better? So remember that plutonium is much better than the uranium. Okay, plutonium is much better than the uranium. Plutonium is the best fuel. We can convert into plutonium using this simple reaction. But only one line you have to remember: plutonium is much better. Okay, this one I am skipping here. No need as of now. And this is the part of the reactor. And okay, so. And this is the nuclear fusion. If they ask which one is better, then always fission is better, because in the fission per nucleon we are getting more energy. Okay, so this is the one question in the fission we have asked in the last examination also, that when fusion is achieved by raising the temperature of the system. Okay, why we are raising the temperature of the system? So that enough kinetic energy to overcome the coulombic repulsion, because you know that one is positive and one is positive, they cannot they are having strong repulsion, they cannot come close to each other. So very high temperature is needed, so that they have enough kinetic energy to overcome coulombic repulsion. Okay, to overcome coulombic repulsion. When fusion is achieved by raising the temperature of the system, so that the particle have enough kinetic energy to overcome the coulombic repulsive behavior. It is called the and which are the source of energy of the star? We know that your fusion is the we don't have to mug up any of the energy here. Okay, that only this last line you remember. Four hydrogen atom combined to form and 2 He4 with a release of 26.7 MeV of energy. Okay, 4 hydrogen, 4 protons, 1 H1 combined, they are producing your helium, and they are giving this 26.7 amount energy. And listen, helium is not the only element that we can make. Again, what will happen? Helium will also get the fusion. Sometimes this doubt is there that okay, once all the hydrogen is consumed, then what will happen? Solar energy will be stopped? No, it will keep on going. Because when hydrogen converts into helium, helium will also combine, it will form some higher order, and that also will combine, keep on going. So that is written here that helium is not the element that will be okay there. As the hydrogen, the core gets depleted, okay, hydrogen gets depleted, becomes helium, the core starts to cool, and then okay, because of this, what will happen? Okay, when helium will be there, okay, so after some time, okay, this time helium nuclei will convert into your carbon. This kind of process can generate through fusion higher and higher mass number, okay, but elements more massive than those okay, near the peak of the binding energy, means it keep on going for the million and billions of years, okay. So if I say this is the finished actually here, in this one, what are the questions if I say, okay, already I have told you first important question that is coming in the nuclei. That's why I said nuclei will be very quickly, very fast. Nuclei, first one is the your first main important question is the radius based, okay, that you have to remember. Quickly I will revise in the 1 minute all the things. Radius based, R equal to how much here? A power 1 by 3, okay, means R proportional to A power 1 by 3, R naught A power 1 by 3 we can write here. R equal to, we can write in this one, R naught A power 1 by 3, okay. Next thing you have to remember that density is always constant. Liquid drop model, we can explain all the things, and then we can write here, they can ask the ratio of the volume and all the things related to the radius, we can finish. Then energy will be basically your delta M into C square, or we can write delta M into 931.5. Binding energy, they can ask, binding energy will be always, okay, your proton plus neutron minus mass of the nuclei, always mass defect if given, then we can say very quickly this thing, okay. So this one is finished here, okay, because nuclei they have deleted the major part, so nothing is much in the nuclei. All the time nuclei questions will be easy, try to do, okay, all the questions of this one, okay. So now we'll go quickly for the your okay, can I go for photoelectric effect? Photoelectric effect and then optics, or atom now? Okay, so now we'll go for the your okay, okay, optics will finish, okay, we'll finish the optics first of all, and then we'll go for the photoelectric effect also, okay, because that is a very simple okay. So we'll go for the optics now, okay. Optics is also one very okay, large chapter and important all the time, okay. So optics can be easily done. After optics we can take the atoms, okay, because that will not take time. Atom doesn't take time, photoelectric effect will take time, because photoelectric effect means how to explain, so that will take almost half an hour, maybe slightly more also. So we'll finish first of all big, okay, ray optics, okay. Everyone will remember here that wavelength of the visible is always 4000 to 7000, okay, 4000 to 7000 angstrom, okay, visible range. And okay, optics we are going to talk about that only. We know this thing, I equal to angle R, I equal to angle R, angle, okay, your refraction, and laws of reflection are valid for all type of surface, valid for all type of surface, okay, valid for all type of surface. Angle I and angle always same, and valid for all type of surface, okay. And now if I say here in this pen that all the time you have to take which direction is positive, direction of the incident ray is positive, incident ray will start from object, so this direction is positive, incident will start from object, so object to surface is positive, object to surface, that direction is positive, it starts from the object to the surface, that direction is always positive, opposite to that everything negative, in that direction positive, okay. Yes, clear? First of all, upside positive, downside negative, okay. There are the two types of object, real object and virtual object. Which object we have to take most of the time? Most of the time we are going to deal with the real object, because real object only okay, I mean in the reality exists, okay. Virtual object is one concept to solve the question. So because of the virtual object, don't confuse yourself. Real object distance always negative. Real object Negative or positive? Real object you will take negative. Real object distance is negative. Okay. And remember, for the mirror, this front space is always a real space. Anything lying here will be known as real. Anything back side will be taken as your virtual. So this side object real, this side your image real, this side back side then your virtual. Okay. So this in the mirror we can easily decide front space is the real, back space is the virtual. Okay. Focal length you have to remember, okay, that focal length is always, okay, for the mirror it is the r by 2. Focal length is r by 2. Of course this is for the paraxial rays. We only plane mirror important hai kya? Plane mirror is not given in the NCERT. Whatever is not given in the NCERT means that is not going to be directly asked, but whatever is there in the notes, at least that much you have to do. Okay, in the notes whatever is there, that you have to revise. Okay. Yes, so focal length is r by 2, but this is for the which type of rays? Paraxial rays, and in our syllabus we only consider the paraxial rays. Remember, focal length, okay, focal length only depends on r. It does not depend on the medium. It does not depend on the wavelength. Okay, means for mirror, okay, I am writing this one. For mirror, focal length f, okay, depends on what? It depends on r. We can say depends on r. Okay, here I can write independent of, okay, your what? Medium and lambda. It does not depend on medium and lambda. If I keep in the water, mirror focal length will not change. Mirror focal length will not depend on the color also. Red color, violet color, green color, any color, focal length will remain same. Focal length is just r by 2. Okay, r by 2 you have to remember. So now we can see here in this one that these are the parallel rays coming, and parallel rays will meet at one point. This point is basically known as what? Focus. Okay, and listen, all the rays do not meet at one point. Okay, all rays do not meet at one point. These only I am taking the paraxial rays. Okay, if this mirror is very large, okay, and mirror is very, very large like this, and if I have one ray which is close to the margin means close to the edges, and if this is the ray, then this ray and this ray, both the ray will not meet at same point. So there is the one focus, or so many focus are there, so many focus can be there, so that can be confusing for us. That's why these marginal rays we don't consider. Marginal rays are not considered. We only consider the paraxial rays, and all the paraxial rays will assume they will meet at the same point. Okay, but each and every ray don't meet at the same point. Last time one question was also asked, okay, when okay, if I say this ray and this ray will meet at the same point or different points, this ray will be meeting here, somewhere here, and these ray are meeting somewhere here, so they are having different focus. This problem is there. This is the problem in the mirror. This problem is known as your spherical aberration. This problem is known as spherical aberration. What the spherical aberration? All the rays do not meet at the same point. All the rays do not meet at the same point, known as spherical aberration. Okay, all rays do not meet at the same point. So all parallel rays, marginal rays, paraxial rays do not meet at the same point. This is known as your spherical aberration. How we can reduce this spherical aberration? Two methods are there. One, you can block the marginal, one point, block the marginal. Okay, block the marginal. Or second is use the parabolic mirror. Parabolic mirror, in the parabola there is the property, if you are using this parabolic mirror, then what happens in this one? Basically any ray, okay, either like this, anywhere it is there, okay, all rays will meet at one particular point. Okay, so we can say in this one basically all are going to meet at one point. So to reduce this spherical aberration, what is the best method? To use which type of mirror? To use which type of mirror? Parabolic mirror we have to use. Parabolic mirror we can use. Okay, sometimes question can be asked that you know that in the solar panel, solar panel is there na, or maybe somewhere, suppose you have to focus, you have to, okay, focus all rays at one point. If you have to focus all rays at one point, can you use convex? If you have to focus all rays at one point, can we use the convex? No, because convex is converging or diverging. Convex is always diverging. So it will not focus at one point. This one is converging. Okay. So if you have to focus at one point, if you focus at one point, so we can say, can we use convex? No, that is the diverging. Can we use concave also? Answer is no. Which one is the best one between your concave and parabolic? Which is the best one? Parabolic is always best one. Okay, parabolic if you use, then your then spherical aberration will not remain there. Okay, clear? So basically all will meet at one point. Parabolic means all will use will meet at one point. So parabolic is always used. Okay, parabolic is all the time used. Parabola type we use. Okay. Yeah, yesterday also question was asked that to remove the spherical aberration in the telescope, which mirror we use your parabolic mirror. Okay, so in case of this one, all do not meet at the same point. So this is the one problem known as your spherical you got here. Okay, all the rays meet at here we can say this is known as your focal plane here. Okay, this is the formula we know, independent of for F equal to R by 2. Then coming here, mirror equation, everyone knows the mirror equation, 1 by V plus 1 by U equal to 1 by F. We'll do directly one question on this one, 1 by V plus 1 by U equal to 1 by F. Listen, everyone how to remember this ray diagram. I hope you know. If you don't know, then I'm writing here because ray diagram needed to solve any question. So I'm just writing the summary. This is the F. This one is the your C. This is the infinity. When object at the infinity, image will be at the focus. Object beyond C, it will be between C and F. But when object is very, very far, these two are very small. Okay, with respect to C will tell which one is far or which one is center will tell. Okay, center will give you idea which is far or which is closer. So if you are away from the center, you are very far, image will be very small. Okay, when you are at C, it will be at the same size. When you are at between C and F, then we can say image will go beyond C. When you are at the focus, it will go to the infinity. So you can remember like this, means this is the number 5. That 1, 2, 3, 5. When object coming closer, image keep on going away. Object coming closer, keep on going away. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Object upside, but aha represent all these. Okay, this is the same size. And then we can say here, this is the your here we can say these two are the large. Okay, all are in the front all are real and all are inverted. Okay, all are inverted. So you remember real and inverted. Then there is the one more position, 6. In the 6 it becomes too close. If it is very, very close to the mirror, then it will go backside, and then we can say it will be here. Backside is always virtual. This one is the enlarged, virtual, enlarged. Okay, and erect also. So you have to remember. So if I say concave mirror, okay, concave mirror, if I say forms these type of image. If your real object is there, then we can say for the real object it gives you real image as well as it gives you virtual image. But virtual image is always what? In large. Virtual image is always in large, but real image is your real image is your in large also. It is your same size also, and it is your diminished also. Okay, so this is the summary of ray diagram for the concave mirror. You have to keep in the mind. Yes, real object, concave mirror produces for the real object real image. That real image is big, small, same size, but virtual is always bigger. Virtual is always bigger. Can you remember this whole thing? Virtual image produced by the concave is always bigger. Okay, always bigger. Okay, so in this one so many positions are there, 6 positions are there for the concave, but for the convex we have only single position. For the convex I will draw diagram in the next. Okay, only single position for the convex. In convex you can put anywhere. You are putting object anywhere, object in front of mirror. You can keep object anywhere. If I'm keeping object anywhere, ray will go like this. It will appear that it is coming from the focus. Okay, and then we can say another, you can take at the optical center, and then we'll be going like this. If you extend back, then we can say here we are getting the image formation. So always image is, you can say backside. So backside all the time, this is the your virtual, this is the erect, but it is diminished. So we can say convex mirror. Okay, for the convex mirror, always you have to remember, for the real object, image is always virtual, but this virtual is always small. This virtual always is small. You have to keep in the mind this thing, okay? And this is always between pole and focus. You are keeping anywhere all the time between pole and focus. Yes. Only one position, that all the time real object virtual, and it will be between pole and focus, it will be always small. Okay. Now, if I say magnification, because most of the questions you will solve using the magnification, so you have to remember the magnification. Magnification is basically equal to your Hi by Ho equal to, we can write minus of V by U equal to F by F minus U. This is the formula for magnification. Everyone have to remember magnification. Hi by Ho equal to minus V by U equal to F by F minus U. You can remember magnification positive. Positive means basically erect, and when erect means it is the, we have seen all the erect here virtual. Magnification negative means we can say your it is the inverted, and we have seen till now all the inverted were your real. Can you remember like this? Okay. So this magnification things also you remember, because sometimes they will say double size. Okay, one question I will take, and then we have to solve this one. Okay, so ready? Then I will go for the NCERT questions also, because these questions not given the NCERT. Okay. They are saying object is placed, okay, like this. Object is placed, okay, and okay, at a distance, at some distance, okay, at some distance. This height is basically you can say 10 centimeter height is there, okay, or I can say nothing, no height is given, and this is kept at some distance. Mirror forms double size real image. Everyone knows double size real image means magnification will be negative or positive. We can say M is 2, but real image, real means inverted, so M will be the minus 2. Double size inverted means M is going to be minus 2. So now we can say, okay, they will give you the radius is suppose 40 centimeters. We can write focal length will be equal to how much? Focal length becomes minus 20. Focal length of the concave always negative. So I will put here M equal to minus 2. Why I got minus 2? Because double and double size and real. Real means basically your inverted means minus I am putting. We can use the formula F by F minus U equal to minus 2. F is minus 20. Divide by minus 20 minus U equal to minus 2. Can we do the cross and get the answers? Yes, we can cross and get the answer. These type of questions can we do? We are asking these type of questions and you are not doing. Some of you, okay? Yeah, okay, we can do, okay? So you have to remember that from the magnification, I am positive and negative, okay? Okay. One more thing I will say about the magnification, you have to remember that in this, okay, I can write all the magnification. This is the your, okay, here 0, this is the 1, this is the 2, this side I can write 3, this side I can write minus 1, minus 2, okay? Remember, plus 1 magnification is only for the plane mirror. Plane mirror magnification is always plus 1. Magnification of the plane mirror is always plus 1, okay? 0 to 1 is for the convex mirror, okay? 0 to 1 is for the convex mirror, okay? Convex mirror. And concave has so many positions. So this side, okay, we can say your concave mirror can have any values. In this side also, inverted only possible in the concave. Inverted only possible in the concave mirror. So we can say, because you know, erect and erect, positive means erect and bigger is only possible in the concave. Because in the convex it is always small. It will be always less than 1. Okay. So this is the one. Okay. Means line diagram. You can remember all the magnification here. So you can easily guess. Plus 1 is for the plane mirror. 0 to 1 is only for the your convex mirror. Other will be all the positions are for the concave mirror. Okay. So let's Go to the NCERT again here. So they are saying that lower half of the concave mirror is covered with one non-reflective material. Okay, opaque means non-reflecting material. Then what will happen? Nothing will happen. Okay, each part of the mirror will make the image. Each part of the mirror will make the image. Okay, so image will be formed if you cover some part. Even though this much part is left, that much small part will also make the image, but of course intensity will not be that much great. Intensity will be reduced. Okay, so intensity will be reduced. Clear? Intensity will be reduced. Okay, now so now we are having this question here, that this mobile is lying on the principal axis. I will take this question as the numerical because I feel they can ask one numerical on this one. This is given as it is. I will, okay, this is the, you can read the question and then we'll, okay, take as the numerical this question. Okay, listen. So we have here, they will suppose if I am taking here length of the mobile, I am taking suppose 10 centimeter. Any problem? And height I am taking 5 centimeter. I am solving the numerical question for this mobile. Okay. And in this one, I am taking its focal length 20 centimeter. So its radius becomes how much? 40 centimeter. Okay. Is I can write here focal length is, okay, 20 centimeter. So radius becomes 40 centimeter. Okay. So everyone very clearly can say, sir, this distance here to here is how much? 40 centimeter. They have given theoretical. I am going to take the numerical question on this. Okay. So now we can see here, this part, this mobile is having two, okay, one here and one here. Okay, so these two I'm going to take. This is the B part, this is the A part. So B, if you say B is exactly at okay, C. If B exactly at C, then its image will be also at C. B exactly at C, so image will be also at C. If this question means they are asking, this will be of course a little bit calculated. That's why they have given only theoretical here. I'm taking as the numerical. So we can say this will be at the C only for this one. Okay, so this is the B dash. But A is between C and F, and A between C and F, its image will be beyond C. But this is okay. This point A is close to the mirror, so this will be the bigger. So here we are getting the this A dash point. Okay, this is the A dash, and then we have to find this is the length of image. This is the length of image, and this is the your height of this one. Okay, so of course it will appear as the your trapezium type. Okay, so length of the image we have to find. Ready for the length of image? Okay, so we can say B is basically at what distance? B is at the 40 centimeter, and if B is at the 40 centimeter, then this will remain as it is. So only we have to solve for the B or A. Only I need to solve for A. Only for A. So I will solve for A. So I can write here this one for A. Okay. So for A, if I say object distance, you can say, sir, object distance because this length is 10. So object distance will become how much? Because total is 40. So here to here this becomes how much? 30 centimeters. So I'll write U equal to minus 30 centimeter because you know object is always going to be negative. Okay, object is always going to be negative. Then we'll use the formula 1 by V plus 1 by U equal to 1 by F here. So 1 by V plus means minus 1 by 30 equal to 1 by F means 1 by 20. You can take this thing that side. So we can write here 1 by V becomes here 1 by 20 plus 1 by 30. So now you have to, this F is your negative all the time. This is the concave, so we can write here minus. Okay, so you will solve this one. So if you are solving here, directly I can write, or no problem, you can take the 60 LCM here. So now we can write 60. So this becomes minus 3 plus 2. So V becoming here how much? Minus 60. So we can say this A is coming at the what distance here? 60. So we can say B is at the 40, but A is coming at the 60. So tell me the length of image here. What the length of image? This length. What the length of image? Length of object 10. Length of image is length of image. You can say this end is at the 40, this is at the 60. So length of image, this is the length. Length becomes how much here? Your 20 centimeter. I hope this question is clear to you. They may ask the same question as it is. Okay, they will say mobile lying like this. What will be the length of image of the mobile? Can you find this length? Finished? Okay, very good. So next question we are having here in this one, change. So this is the theoretical given, we have done like the numerical. Next question coming here again same. An object is placed at the 10 centimeter, next time at the 5 centimeter, two parts are given, and they're asking find the position and nature and magnification of the image in each case. So one case I can solve, one is already solved here. So one I can solve, okay. So we can write here in this one I will do, whatever is that, okay. Don't focus on this. So we can say focus radius is given how much here? 15 centimeter. So we can say focus will be how much? 15 by 2. But which one? Positive, negative? Negative, because cave given. Then they are saying that it is kept at the 10 centimeter. 10 is solved, so I'm going to solve for 5. So we can say u equal to minus 5. So we'll use 1 by v plus 1 by u equal to 1 by f. So 1 by v and minus 1 by 5 equal to 1 by f. 1 by f means how much here? Minus 2 by 15. You will take that side. So 1 by v equal to becomes minus 2 by 15 plus 1 by 5. 15 is the LCM here. So we can say this becomes 15. Clear? Now they can ask magnification. So we can say magnification equal to, we can write minus of v by u. So minus 15 divided by minus, okay, 5. Answer becomes how much here? 3. Plus 3 means this is the your erect and magnified as well as virtual, because plus means virtual. But this is the second part I have solved. First part I have not solved. Okay, one part you have to do, one part I will do, one part I have done. Okay, first part you will do. So we got here magnification is 3 and it is the your erect also. Second part is solved here. Okay, so we got magnification is 3, image is magnified, virtual as well as erect. Can we do? Okay, question, first part you can practice. And this is the question given as it is question. Either one question for the magnification that I had told you earlier. Magnification, either length of the image. They will not go beyond this one, okay? Length of the image, magnification, or, okay, this one is there. This is the velocity related question. And for the velocity, listen, they have solved here using the average. Average and instantaneous both are same if time interval is very, very small. Okay, sometimes NCERT also writing the okay short okay form, but that is not correct. So we'll not go by the NCERT method, that is the average method. We have to go by the instantaneous method. And for the instantaneous, this is the formula written here, that velocity of image with respect to mirror is always given by m square velocity of object with respect to mirror. M formula is f by f minus u. Okay, so you have to use only this formula for the velocity of image all the time. Don't go by the average method. Okay, they have done here average method. Only rely on this formula to get the answer. M square v o m. M is the f by f minus u, not by this one. Okay, refraction, we know that okay, that going into the other medium, when rays going into other medium, rays going into other medium, rays going into other medium, then its velocity will change, but frequency will not change. So velocity and wavelength, two things will change, but frequency will remain same. This is the Snell's law. We know all the time that okay, Snell's law very clearly we know. Okay, now one word I have underlined here. Okay, one is the your mass density, one is the optical density. Okay, your refractive index is sometimes referred as okay, refractive index is referred as your optical density. So optical density and mass density both are not same. Remember, optical density should not be confused with the mass density, which is the mass per unit volume. Okay, it is possible that mass density of the optically denser medium may be less. Okay, for that example is there. Okay, optical density means basically what? Refractive index. Okay, for example, turpentine and water, mass density of okay, turpentine is less than that of water, but its mu is more, optical density is more. So mu and rho both are not same. Okay, both are not same. Mu and rho density both are not same. You have to keep in the mind. Okay. Okay. So now in this one, okay, this is the one, okay, real depth and apparent depth. Okay, so for the real depth and apparent depth, you have to remember this formula: h dis equal to h by mu. H dis equal to h by mu. Okay, you have to keep in the mind. Okay, that h dis equal to h by mu means object is actually here, but object will not appear here. Object will appear somewhere upside. Okay, and if actual depth is your h, then it will appear at the depth h dash, and where h dash is equal to h by mu. H dash is always h by mu. Okay, h dash becomes h by mu. So this formula you have to remember. They will ask the question. I will ask one question here. They will say that one coin is placed at the bottom of, okay, one slab. This slab thickness is 12 centimeter and mu of the slab is 3 by 2. Okay, they will ask at what depth, okay, image of coin, okay, will be formed. At what depth image is formed? Okay, at what depth image is formed, we can say image will be formed at the depth h dash, which is h by mu. So we can say 12 divided by 3 by 2, it becomes basically how much? 8 centimeter. So this okay, image will be, object is at the 12 centimeter, but image formed at the 8 centimeter. Okay, image is formed at the 8 centimeter. Can we do like this one? Same question they can ask for this also, that this is the your water, and here in this one, okay, coin is here and then some water is filled. Okay, then where its image will be formed or where it will appear. So you have to use all the time formula h by mu you have to use. Okay, now this is the one question. Earth takes 24 hours to rotate once about, okay, its axis. You know, in the 24 hour it is taking full rotation. Full rotation means almost 360 degree. So we can say 360 degree total shift happening in the one okay, 360 degree shift happening in the 24 hour. So how much will the one shift, 1 degree shift means we can say 360 shift happening in the 24 hour. So 1 degree shift happening in how much? 24 divided by 360. 24 by 360 means how much? 4 minutes. Yes, 24 by 360 means 4 minutes. Clear? Very basic question. This is nothing. Okay, if they are asking, we can do. Okay. This one I am, okay, skipping that part. So now in the TIR you have to remember only two things. Okay, first of all, TIR should be denser to rarer, and for the TIR, okay, remember I is always more than theta c. Okay, theta c at which, okay, your r equal to 90, and you have to remember sin theta c always equal to, sin theta c is mu r by mu d. Remember this formula, sin theta c is mu r by mu d. Three things: denser to rarer, angle of incidence is more than critical angle for the TIR, and for the theta c critical angle at which angle of refraction becomes 90, means rays goes parallel, and sin theta c is mu r by mu d. You know, mu and velocity relation is direct or inverse. Mu and velocity relation is always inverse or direct? Inverse. So we can say mu r by mu d will be basically your Vd by Vr, or we can say lambda d by lambda r. Okay. Recently we are asking these questions. Okay. Yesterday also asked, before that also asked, and they have also asked in the PYQ question on this one. Like I can say that velocity in two mediums are 2 into 10 power 8, and they can say here 1.5 into 10 power 8 meter per second. Okay. 2.2 into 10 power 8 and 1.5 into 10 power 8. They will ask what are the critical angle. So here's a sin theta c will be equal to how much? Vd by Vr. So much will write 1.5 divided by 2. Okay. So answer becomes how much here? 3 by 4. Can we do like this? Anna? Remember, if by mistake you have written 4 by 3 also, if you are written 4 by 3, then keep in the mind sign cannot be more than 1. Sign will be always less than 1. So we can correct our mistake. Okay, ratio of the velocity you have to take. Okay, if you forget the formula, then you have to take the ratio of the velocity or ratio of the wavelength, and it will be always sin theta always less than 1. So you have taken, okay, If you have done the mistake, you can just correct the mistake by taking the value less than 1. Next question, I can take lambda equal to 6000 angstrom, and lambda 2 I can say 4000 angstrom, and again I can ask the same question, sin theta c. So yesterday, sin theta c becomes how much here? Your 4 by 6. Okay, if by mistake somewhere you have written 6 by 4 also, then also correct your mistake, because sine is always less than 1. Okay, so we can write like this, sin theta is equal to 4 by 6. Clear? Okay, so these are the some simple questions on the TIR. Okay, one D2R theoretical question, this one, and sin theta c mu r by mu d, vd by vr, lambda d by lambda r, and then question. Okay, now in this one, these one I will not say to mug up. You can only remember for the diamond. Only for the diamond you can remember this data, that its refractive index is 2.42 and 24 degree. Okay, 24 degree, 2.4, 24 will be easily remembered. Okay, data is symmetric, 2.4 and 24. Yes, it is having highly refractive index. Diamond is spark. Okay, diamond is having some shining. Okay, because of what? Highly high refractive index. Okay, this is the some in this one, I'm not going into detail. Thus, you remember that TIR example. What are the example of TIR? One is the mirage formation. Mirage formation. In this one, you have to remember temperature more, refractive index less. One point is coming from this paragraph. Temperature more, your refractive index will be less. Okay. And remember that mirage formation is the example of TIR, and I'm not explaining this whole phenomena here, not possible. Temperature more, Ri less. This is the one conclusion. Okay. So, you have to remember temperature more, refractive index less, means because of the difference in the refractive index, we are getting this mirage formation. Okay. Because somewhere air becomes warm, and then given here, the diamond is having brilliance. Only one line you have to remember, because of the higher refractive index, its critical angle is 24. It's 2.4 in the your refractive index. Okay, so that is there here. And then for the optical fiber, you have to remember two things. Okay, that this is the core, inner part. Okay, core, and this is the covering. This covering. Okay, this covering is known as your cladding. Okay, this cover is there. That is known as your we can say that is known as cladding. So remember, refractive index. Okay, refractive index of the material of the core is higher than that of cladding. Okay, more than that of cladding. Okay, yes. And which type of signals we are sending are extensively used for transmitting audio and video signal through long distance. Optical fiber too must make use of the TIR. Optical fiber also based on TIR. Core is having more refractive index. More refractive index. Okay. In this one more line you can remember, that at what angle we have to send this signal. This we are sending this signal at I. This sine I is basically root of mu core square minus mu cladding square. Okay, mu cladding square. If somewhere they want to ask a direct numerical, formula based numerical, then we can say at what angle we have to send sine I equal to mu core square minus mu cladding square. Mu core minus mu cladding square. Okay. So mu core minus, so these are some examples of TIR that you have to remember. Refraction at spherical surface. I'm feeling that they can ask the same question which is given in the NCERT. Same question, okay? And this is written, so I will solve the same. This is the formula, first of all, you have to remember. Mu2 by V. Mu2 by V minus mu1 by U equal to mu2 minus mu1 by R, okay? Mu2 by V minus mu1 by U equal to mu2 minus mu1 by R. Okay, you have to keep first of all mu2 by V minus mu1 by U equal to mu2 minus mu1 by R. Mu1 is for the first medium, mu2 is for the second medium. Okay, mu1 for the first, mu2 for the second medium. Okay, U and V already well we know, object distance, image distance. Okay, so this is the question. Because they have not asked, so probably chances are there. Very easy question. They are saying a light from the point source in air falls on the spherical glass surface. This is the glass surface. Its refractive index is given 1.5. Its radius of curvature, radius is given here. If you say r equal to 20 centimeter, and okay, this is the object because in JMIN also they have asked the same question. Yes, this is the object. Object is at the 100 centimeter. Okay, 100 centimeter. This is the question given. They're asking where image is formed. Very simple question. Okay. Very simple one here. You have to use the formula. For the formula, basically, I will write here mu2 by V minus mu1 by U equal to mu2 minus mu1 by R. Okay. Now we have to take the sign convention. Take by default object distance negative, or we can say this direction is positive. Direction of the incident ray is positive. Ray starts from object to the surface. Object to the surface is positive. So we can say U becomes here minus 100. U is minus 100, but R, all the distance will take from here. So this is negative, but R will be positive. So R becomes plus 20. Now we are ready. Mu1 will be 1 because object in the air, and mu2 we can say it will go, okay, ray will go that side, so 1.5. Let's solve. Mu2 means 1.5 means I can say 1.5 is 3 by 2V minus mu1, that is the 1. U is minus 100, so minus plus, equal to mu2 minus mu1 means 3 by 2 minus 1 divided by R is 20. Okay, so we can write 3 by 2V plus 1 by 100 equal to, we can say 1 by 40. 100 you will take that side, so 3 by 2V becomes basically 1 by 40 minus 1 by 100. So we can write here in this one what will be the LCM. We can take 200 in the LCM. This becomes 5. This becomes how much? This is the not means we can say here in this one. So this is the 200. So this becomes 5 minus 2. So now we can write here that 3 by 2V. So 3 by 2V equal to 3 by 200. Yes. So 3 cancel and V coming how much? 100. Yes. Okay. So now we can solve these type of questions also. This is a very important question. Very simple. Practice one more time the same question. Okay. One more time practice needed here. Okay. Then refraction by lens. This is the lens maker formula. Two questions always important here. One is the combination of the lens. One is dipping in the medium. Okay, so both I will take here. 1 by F formula. First of all, you remember mu L by mu M minus 1 by R1 minus 1 by R2. Okay. Now, because those questions not given, so I will. This is the lens formula. The ray diagram is exactly same as the mirror, just opposite, exactly opposite. Okay. One thing here, magician during the show makes a glass lens with 1.47 disappear in a liquid. What is the refractive index of that liquid? You can see it will only disappear whenever both mediums are same. If both are same, then it will disappear. Okay, you will not be able to find. Okay, it will disappear. Remember this thing. Mu lens is more than mu m. Nature will not change. Nature remains same. Okay. Nature same. Mu L equal to mu M. Okay, means it will disappear. It will disappear. We cannot find, means in this case basically your power becomes 0. Focal length is infinite, and it will disappear also. Okay, we cannot identify. Not identified. Okay, means act like the plane surface or not identified. Number 3, we can say mu L is less than mu M. Okay, surrounding medium is more. Surrounding medium is more than nature will change. Nature will change. Nature will change means your converging becomes diverging. Diverging becomes converging. Converging, diverging, and diverging, converging. Okay, when you are putting in any medium, this is the formula 1 by F. Okay, if you say equal to mu L by mu M minus 1. Okay, so you know that medium is directly proportional to focal length. So in any medium, because from air, with respect to air, any medium is always going to be denser. Always any medium will be the denser. So when you are putting in any medium, focal length increases. Means in a medium, okay, in a medium, focal length increases, F increases, and power decreases. F increases, power decreases. Okay. F increases, power decreases, and then these points you have to remember. that nature will change and when nature will not change. Okay, if lens is dominating, nature will not change. If lens is not dominating, medium is dominating, nature will change. Okay, and dipping in the water, dipping in the means depending any of the liquid. Okay, we can say focal length more, power will be less. Okay, this is the power formula 1 by f, we know, so we can easily do. This is the one question here. If focal length is 1 point, okay, very important question, and focal length is given 0.5. 0.5 is the focal length, so we can say focal length is 0.5 meter given here. They are saying what is the power of the lens? Power, anyone can solve. Power is nothing but the 1 by f. Becomes so much here. 2 diopter question finished. First part is finished. Okay, finished. Now we can say second part. They are saying radius of curvature of the faces of the double convex lens are 10 and 15. Focal length is 12. Very important question. The second part. Okay, they are saying that one is the 10, one is the 15. Focal length is 12. What is the refractive index of the glass? Okay, I am taking this question separately in the board here. 10, 15, and focal length is 12 here. Okay, so I can say here. Okay, let's. Where is that? So I can say they are saying in this one that this is the 10, this is the 15, and focal length is coming 12. You have to find the mu. Okay, so now we can write ray coming from this side, then this becomes your R1. So R1 becomes positive, and this your R2, but R2 will become your minus. So let's solve. So 1 by f equal to, this is the formula, mu L by mu m minus 1 into, we can write 1 by R1 minus 1 by R2. So focal length we can write 1 by 12. Less we have to find. So mu, air we can take 1 because it is kept in the air. 1 by R1 we can take 10 minus minus plus 1 by 15. Okay, so we can write here 1 by 12 equal to here mu minus 1, and 10 and 15. 10 and 15 LCM will take how much? 30. So this becomes how much here? 3 plus 2, so 3 plus 2, so we can write here 1 by 12 actually equal to mu minus 1, and this becomes 6 by 30, and 6 by 30 each 1 by means not the 6 by 5 by 30, so this becomes 1 by 6, 5 by 30, 6 and 12 will be cancelled, so we can write here mu minus 1 equal to how much here? 1 by 2, so mu becomes how much? 3 by 2. Can you solve this type of question? If this type of question coming, can we do? Okay, very good. Okay, so expect something like this to be coming, where you have to find the mu. Sometimes they can give the mu, they can ask the focal length. Vice versa question also can be there. So we are ready for both. Vice versa question also can be done. Okay, so this is there. Okay, and then is the next is the third part. Okay, that convex lens has focal length 20 centimeter in the air. What is focal length in the water? And this is also one one important pattern. So in the I will take for this also one separate page. They are saying focal length. There are same 3 questions are given as together. Focal length in air. So we can write 1 by f equal to basically mu L by mu m minus 1. And when we are changing the medium, we are not changing the radius, and we are not changing the radius means C will remain constant. Okay, so we can say for air 1 by 20 equal to mu L. Okay, length is your 3 by 2, so we can say here 3 by 2 mu air 1 minus 1 into C. So 1 by 20 equal to, this becomes how much here? C by 2, equation number 1. So C becomes here 1 by 10 fixed. Okay, multiple times it is they have asked. Okay, so C is 1 by 10. They're asking in water. So we can say in water we'll write the same thing, 1 by f w equal to here mu length 3 by 2, water will be 4 by 3 minus 1 into C, and C will be how much here? 1 by 10. So we can write here 3 by 3, 9, 9 by 8 minus 1. So that becomes 1 by 8 into 1 by 10. So we can say this is 1 by FW. FW becomes how much? 80. Yes? Can be done? Okay, so this also we can do. If I am giving one homework, one practice, because one practice needed. If we are keeping in the 2, if you keep in the 2, medium 2, okay, not in the water, you are keeping in the liquid of medium 2, okay. solve this, repeat the same question, that if this lens is placed in the medium of index 2, okay, placed in the medium of index 2, you have to repeat the same question. Yes, can we repeat? So this okay, one very important question, all three parts are there, that is done, okay. And now this is there for this formula, you have to remember that, yes, what are the formula? P1 plus P2, okay, combination P1 plus P2, okay, total is the P1 plus P2, okay. Now this one you will see, this is the one AG, they have asked as it is question in the JEE Main April session. In the April session, exactly same question they have asked, okay. It is very simple. First this will make the image, okay, first this one is making the image. When they are going to ask in the NEET, they will only give you 2, they will not give 3, okay. Chances are they will only give the 2, and then the image formed by the first will act like the image, or I can, okay, quickly tell here in this one already, because I have solved to okay, save the time here. So in this one, first one, okay, at the 30, when it is at the 30, we have solved, we got how much at the 15, okay. So we got 15, that also here 15. Then they are saying image formed by the first lens serve as the object for the second. This is at the distance 15 minus 5, because you know in this case this is at the distance of 10, and we got okay, from here first one when we are solving, we got that image will be basically at what distance? 15, image will be coming at the 15, but this is of 5. So from the second lens, if you say from this lens, object distance will be what? 10. Object distance will be 10, okay. So that is written here, that object distance is 10 to the right of the second through the images, okay. So it will act as the virtual, and then they are, okay, 1 by V2 minus 1, then solve V2 coming infinity, and then this V2 will act like again object for the third one, okay. So again solve third time, 1 by V3 minus 1 by infinity equal to 1 by 30, okay. You can take screenshot of this one, okay, full solution, okay, solved here, okay, and then you can try one time this question, okay, it will be much better. Maybe whatever question they will ask will be a very easy one, easy pattern of this can be given to you, okay. Then prism is coming. In the prism, okay, first you have to remember this formula. Deviation is always equal to, deviation is I plus E minus A, okay. This and minimum deviation, at the minimum deviation I and E both become same, and when both are same, this becomes 2I minus A. So for the minimum deviation we can say 2I minus A. Minimum deviation will be the 2I minus A, and deviation is basically I plus E minus A, okay. Deviation graph when we see, then we can say this is the graph of the deviation, that is there like this. Sometimes they can give the data, so we can say corresponding to this point, this is the your okay I, corresponding to this one, this will be the your E, that I can take as the 70, and they will say A as the 60. So we can say like the deviation, or deviation is given, so we can find, okay. So like 50 is given, so I can use the deviation equal to I plus E minus A. So deviation is 50 given here, I is 40, E is 70 minus A. So 40 and 70, this becomes how much here? 110. A becomes how much? 60. Can you solve question like this? They have given the graph, but I can make the question from the same data. 40 given here, 60 given here, 70 not written, 70 written, and then exactly same question is framed from NCERT as it is. A you got 60, and okay, then we can solve the question whatever they are asking in this one, okay. R is always A by 2, okay. R is always A by 2, and you have to use always this formula, mu equal to sine I by sine R, okay. Like in the same question, if I say same question I can make, I can give here 45, okay. You know, so mu I will ask in the same question, so you can say sir sine 45 divided by A was 60 we got, so R will be how much here? Your 30 in the same diagram, and mu is sine I by sine R, so we can say sine 45 divided by sine 30. We can solve here sine 45 1 by root 2, sine 30 1 by 2. Answer becomes how much? Root 2. Can we solve the numerical based on the graph? Two numerical I have told. One is that they have given the deviations, we can find A, and second we can find the mu also, okay. I will just add the 145, and then we can say yes, sine I by sine R, okay, sine I by sine R. So we can write here, Okay, and this time a question you can expect only from the deviation because dispersion is not there. Okay, if prism is thin, for thin prism, okay, for thin prism, okay, you have to remember deviation is always mu minus 1 into A. For the thin prism, what is the deviation? Mu minus 1 into A. For the thin prism, mu minus 1 into A. Can you remember? For the thin prism, deviation will be mu minus 1 into A. Last time question was asked, mu were given, and then deviation was asked that del 1, del 2, del 3. So we can say del, okay, will be proportional to mu here, and we can easily calculate deviation for the thin prism, mu minus 1 into A. Dispersion part is not there. So now this one, okay, I'm skipping here. This time they have deleted this. Earlier it was important, but now, okay, it is over. So last thing is coming here in this one, rainbow also, okay, not there. So we'll go for the okay, microscope and telescope. Listen, I also not there. Directly we have to go for the microscope and telescope. Okay, yes, is defect of I. So listen, microscope, okay, first of all there is a simple microscope. This is the diagram for the simple microscope. Like this is the object, we will make the image, position number 6. So only one formula you have to remember for the simple microscope. Formula is magnification power equal to D by Fe, okay, or magnifying power is 1 plus D by Fe, just this thing. This one is when image formed at image formed at infinity, and this one is basically when image formed at D. Which one is the maximum magnification? We can say this one is the minimum magnification and this one is the maximum magnification, and D is the distance of clear vision 25 for the normal person 25. Focal length will be given. Focal length will be given like D is 25, Fe I will give 1. So we can say minimum will be what? 25. Maximum will be how much? 26. Okay. So if they are asking maximum means 1 plus D by Fe, minimum D by Fe. Okay. Minimum will be your D by Fe. Sometimes they will give you maximum magnification is 6. Maximum magnification is 6. Okay, then they will ask for the focal length. We get 6 equal to 1 plus D by Fe. So D by Fe becomes how much here? 5. And D is how much? 25. So 25 by Fe equal to 5. So we can say, we can write here in this one how much? Answer is 5. Okay, so D by Fe or 1 plus D by Fe, that is enough for the simple microscope. Okay, D by Fe or 1 plus D by Fe. Okay, question also very simple questions are asked. Okay, now next one is coming basically here your compound microscope. Okay, because single lens is producing very less magnification, so we are putting here one more, that is known as your okay, compound microscope. In this one what we do, we are putting one more lens, and by putting one more lens magnification is increased. Okay, by putting one more lens magnification is increased. Listen here, so in this case magnifying power, if I say, it will be simply MO into ME. One is the objective, one is the eyepiece. Here objective is small in terms of both aperture as well as focal length. Okay, the eyepiece is bigger. So MO into ME, so we can say magnifying power total will be basically MO, and this one we can say D by Fe, or we can write magnifying power becomes here MO into how much? 1 plus D by Fe. So these are the two cases. If nothing is given, then always you have to take the normal mode. Normal mode means infinite mode. Nothing is specified in the question. You have to take always infinite mode or normal mode, means you have to take always this formula, MP infinite equal to MO into D by Fe, and if they specify maximum, then only will take 1 MO 1 plus D by Fe. Okay, so only these are the formula in the microscope for the magnification. Next formula is for the your length. Okay, but for the magnification only this thing you have to keep in the mind, MO D by Fe and MO 1 plus D by Fe. MO is the magnification of objective, because two lenses are there, so total magnification we can say, total magnifying power we can say MO into ME. This will give you MO, this is giving ME, so we can say MO will be MO into ME. So magnifying power for the infinity we get MO into D by Fe, and for the okay means stressed mode, if they are specifying stress mode or D, then we'll write MO 1 plus D by Fe. Okay, otherwise we'll say simply MO D by Fe. Then comes the separation. Separation always, you have to remember this separation length of the tube is always given by VO plus UE. Okay, VO plus UE. UE means basically this distance of the image. So everywhere, either microscope, either telescope, separation is always VO plus UE. Okay, but question they are going to ask only for the relaxed mode, and questions they will ask for the relaxed mode. So for the relaxed mode, image will be, this image will be at the final image will be at the infinity. So for the relaxed mode, okay, and in case of, okay, relaxed mode, this becomes VO plus FE. So you will remember this formula, okay, that mainly we are going to use this one, VO plus FE. Most of the time VO plus FE is going to be used. Okay, yes, VO plus U is the general formula, but we'll use VO plus FE. Can I take one question on this one for the separation? For the separation, I will take one separate question here. Okay, so because this question will remain same for the microscope as well as a telescope. Like this is the question they are saying, this is the your 2 centimeter and this is the 3 centimeter here. Okay, 3 centimeter, and object I am keeping at the, okay, here 1.5 centimeter I am keeping the object. Okay, so they are asking in this case what are the your separation, or what are the your okay, magnifying power. So let's do it here. So what we can write in this one, that I have to, okay, this will be the image. So this is going to be your VO, and this one is going to be what, FE. Nothing told, always VO plus FE you will use. Okay, so object distance, what the object distance, we can say object distance minus 1.5. okay, I can write minus 3/2 because it is better for me to do in the fraction. Okay, minus 3/2. So I will write 1 by V minus 1 by U equal to 1 by F. So 1 by V minus plus 2 by 3 equal to 1 by 2. So 1 by V equal to becomes 1 by 2 minus 2 by 3. Here 6 is the LCM, so this becomes 3 minus 2 to 4. So we can say V becomes how much? Minus 1 by, yes, anywhere we have done the calculation mistake in this one. Okay, no problems we got in this one. Oh, I cannot take this 1.5, I have to take here 2.5, okay, 2.5. So we can say 2.5, okay, that data are wrong taken, minus 2.5. So we can say this becomes minus of 5 by 2, okay, minus 5 by 2. That object should be always more than F, between F and 2F. Here object is always between F and 2F, okay. So we can say 1 by V minus plus, here we can write 2 by 5 equal to 1 by F, 1 by 2. So we can write 1 by V equal to 1 by 2 minus 2 by 5. 10 is the LCM. So 2 becomes 5 minus 5 into 2. So this becomes 4. So V becomes how much here? 10. This is the 10 distance. Why? Because object should be between F and 2F here all the time. Okay. So V, this distance is 10 coming. 10. This is the 10, and we can say this is how much? 3. So what is the length of the tube? Length of the tube becomes VO plus FE. Answer becomes 10 plus 3. 10 plus 3. Same pattern is there in the telescope also. Yes, clear? 10 plus 3. Same pattern will be in the telescope. Can we do? Okay, so remember this thing. Okay. Also, same question is in the telescope. If I ask same question like this, I'm saying for the telescope also, that this is the telescope. And they are saying this one, okay, in the telescope things are reversed. This one becomes bigger. This is the 100 centimeter and this is the 5 centimeter. And I am saying that this object is basically kept at 300 centimeter. So 300 centimeter means basically you will take U equal to minus 300. Can you solve now? Can we solve? Same question. Object is at minus 300. So you will say, sir, yes, we can do here because 1 by V minus plus 1 by 300 equal to 1 by 100. So we can say 1 by V equal to 1 by phi. Answer becomes 155. This is the question for telescope. Okay. So question for the microscope as well as telescope. Because if object is closer, then we can say like this we have to do here. Okay. So again going for the your NCERT backstage. Slightly going, I think probably half an hour late, but no problem. So means there is the telescope coming here. In the telescope, if nothing is, formula is actually, If nothing is specified, then formula is okay FO by FE, and length of the tube they have written here. If you say length of the tube is FO plus FE, listen, length of the tube is nothing but the VO plus FE. But you know, telescope is always used to see. Telescope is used to see very far object, and telescope used to see far object. For the far object where image will be formed, what is the VO? Because for the far object, VO will be FO. So this answer becomes FO plus FE. So main use of the telescope is to see the far object. If you see object is far, then you will use FO plus FE. Otherwise, formula is VO plus FE. Otherwise, you will use VO plus FE. And this is the formula. Clear? FO plus means in this pen. Because listen, this is the one question I can say. They are saying, for example, consider a telescope. Objective is having 100 centimeter. Eyepiece is only 1 centimeter. What the magnifying power? We can say magnifying power becomes how much? 100 by 1 means 100. Magnifying power is how much? 100. Can you find like this? Yes. Okay. And here one point you have to remember in this one. Telescope with, okay, mirror objective are called reflecting telescope. Reflecting telescope, okay, they have several advantages. First, there is no chromatic aberration in the mirror. Second, if parabolic surface is used, then spherical aberration is also removed. Okay, is also removed, and mechanical support is also much less of the problem since the mirror are having lesser weight. So, which is better, refracting telescope or reflecting telescope? Which is the better one? Always remember, reflecting are much better. Reflecting are much better, okay, in which we are using the mirror that are much better, and best mirror that we have to use is the parabolic mirror. Okay, parabolic mirror. Okay, so these are the things basically here over. Okay, and now we'll take one break for the 10 minute, and after that we will start your okay, remaining things. Class probably will go, I think, up to 1:15. I was thinking 12:30. It will go up to 1:15 probably. Okay, 1 to 1:15, whatever time it will take. Okay, so 10-minute break, and it is 11:26. After this, we'll go for the your wave optics and dual nature. Two chapters are left in the 12th. We'll finish the 12th in the 1 hour. Then we'll go for the 11th class also. Yes. Okay. So 10-minute break is there. We'll sharply start at the after 10 minutes. Okay. Bye. Okay, so 10 minutes completed now. Let's finish other chapters. So as of now, we have only completed 3. So now we have a lot of chapters to finish. So now we'll go for your modern we can finish. Okay, yes, modern. So I will take with the atom, because atom also very small chapter. So it'll feel like okay, one chapter also done. So let's finish the atom here. Atom and photoelectric effect. Atom already you have idea about this one, because chemistry it was common. So first model was given by your J.J. Thomson, and that was known as your plum pudding model. Okay, so you have to remember that in that one they said that electrons are scattered just like your seeds of plum. Okay, next model was given by the given by your Rutherford. That was the alpha scattering experiment. Okay, yes, is after this we'll go for that one. So now we can see in this alpha scattering experiment you have to remember 2 things. One of the 3 things I can say. One is your distance of closest approach. One is your number of particles basically here. So remember all the time that number of particles scattered, that angle theta are sine power 4 theta by 2. You have to remember this. The number is always given by and proportional to 1 by sine power 4 theta by 2. This is the graph. One graph you have to remember that particles scattered at different angles. Okay, how this graph, because n and theta relation is inverse. So this graph we are getting like this. I will not say the hyperbola, but like this we are getting the graph. Okay. So first thing that you have to remember that n, number proportional to 1 by sine power 4 theta by 2. Second thing that you have to remember is your impact parameter. Okay. So what are the impact parameter? And this one you have to remember one line. Okay. That in case of head-on collision, in case of head-on collision, the impact parameter is minimum and alpha particle rebounds back theta at the pi angle. Rebounds back. For large impact parameter, alpha particle goes nearly undeviated and has very small deflection theta. Means if impact parameter is large, then angle of deflection is very small. This one is the basic impact parameter, is from the central line. This is the central line of the nucleus. From this central line, whatever the distance is this distance we can define as the impact parameter. And what is our line to remember here in the impact parameter? If impact parameter is 0, then this theta becomes 180 degree. Okay, this line you have to remember that B is 0, theta is 180. If B increases, theta decreases. Okay, B increases, theta decreases. So in the impact parameter, what are the impact parameter? Distance from the central line, and B0 theta 180, B more theta less. Okay, so we can remember 2 things about the impact parameter. Next thing is coming basically in the Rutherford, 3 things are there. One is the number, at what number they are means they are deflected, means n and theta relation. Second is basically your impact parameter. Third is the distance of closest approach. And remember, distance of closest approach, basically this is the one question on that one. That what are the distance of closest approach? So remember that if this is your alpha particle and this is the nuclei is also positively charged, alpha also positively charged. So you have to project with some kinetic energy. But what will happen due to the repulsion? This particle will not be able to go to this one and it will stop somewhere. So this distance that it is approaching is known as distance of closest approach. And we can say at the distance of closest approach, its total kinetic energy is converted to the potential energy, which Ke converted to the potential at distance of closest approach. We can say Ke will be equal to potential energy. We can get K ZE into alpha particle 2e divided by R. Okay, so we can say this R naught we have to find. So we can say R naught becomes basically 2K ZE square by your half mv square. They can ask this distance of closest approach. So we can say distance of closest approach, R is proportional to 1 by m, R is proportional to 1 by kinetic energy, R is proportional to Z. Like these are the some questions they can ask. We have to remember. Numerical chances are less. Okay, if numerical, you have to just put the data here, but theoretical question asking, already they have asked this, M 1 by kinetic energy are not proportional to Z. So you have to remember that K becomes equal to the P. The distance is basically known as your distance of closest approach, the least distance in alpha particle can approach. Okay. Now, these are your electron orbits. For any of the electron orbits, means for any of the stable orbits, always this is the first equation must be valid, that the K, your Q1 Q2 by R square, okay, should be equal to mv square by R. Here we know Q1 is basically what? Q1 will be the ZE, okay, and the nuclei, and electron is moving, so Q2 is basically what? E. You can put, and this equation must be valid all the time for any of the stable orbit. This must be valid always, okay. Second equation is basically angular momentum. MVR is quantized and it is always nh by 2 pi. So for any of the stable orbit, these two must be valid. Any question that will come that will, okay, require use of these two relations all the time, we have to use MVR equal to nh by 2 pi. Okay, from this relation V, I will take the V equal to nh divided by 2 pi mr. And this one I will put in this equation. So I will get the formula of radius as well as velocity. But a lot of time you have to put the velocity, okay, in your questions, that mvr equal to nh by 2 pi means velocity will be nh by 2 pi mr. Is these two equations we have to remember, they will be used somewhere. Remember, when we are deriving the energy, that energy is always, total energy is always negative. Energy, already you remember that if I write the formula of the energy, then you know that here energy is basically total energy. I'm writing this one, that is a minus of 13.6 Z square divided by N square. Everyone knows. If I say kinetic energy, then kinetic energy, your plus 13.6 Z square by N square, and potential, if I write, then potential is twice of this one, so minus 27.2 Z square by N square. But why total energy is negative? Total energy is negative. This implies that fact electron is bound to the nucleus. If E becomes positive, electron will not follow closed orbit. This is true for the satellite also. In the satellite, in the gravitation also, same thing will be there. Okay, this point remains same. And total energy of the satellite is negative. If total energy of the satellite becomes positive, it will not follow on the closed orbit. It will go, it will escape. Okay, for the satellite also, you have to remember the same point. Okay. So these are the energy formula here, and okay. Then we can see these are the your okay, radius formula 0.529 n square by z, and velocity is basically 2.18 into 10 power 6 z by n meter per second. Radius proportional to n square by z, and velocity is proportional to z by n. Okay, this is our question given. I have not marked it important because it's a very easy one. They are saying 13.6 energy is required to separate hydrogen atom into proton and electron. Calculate the orbital radius. Okay, so this is just formula only. That is the, okay, in the ground state we can say 0.53 angstrom, that is written 0.529 angstrom. So from the ground state, what you will get? 0.53 angstrom written, and the 2.18 is written here 2.2 into 10 power 6. Okay, yes, okay. But sometimes okay, you may okay, that this okay, formula they can ask sometimes. Okay, this thing, okay, this formula, how this formula is coming, basically you can say from here half m means we can write here in this one, your mv square by r. Mv square by r is basically equal to k. We can write in this one for the hydrogen E into E square divided by r square. So 1 r cancelled here. So now we can say velocity we have to find. So velocity becomes in this case how much? Your k, okay, in this one means only one E will be there. So we can say k E square divided by this becomes how much here? Your r with the root. We can put the values here. So this becomes E square divided by 4 pi epsilon naught m r only. Okay, sometimes they are asking this one, and we think that from where this formula came, from the first one only, mv square by r equal to k E square, E into E, because both are the E into E, because Z will be how much? 1. In this case, for the hydrogen, Z is 1 divided by your R square, 1 R cancelled. So V equal to root of K square by MR. So you have to keep in the mind, okay? Yes. So this is the first thing. Then coming directly here, atomic spectrum. Okay, in this one you have to remember we have different types of spectrum: Lyman, Balmer, Paschen. I will say that remember this thing that okay, Lyman is there. In this one, remember this at least for the Lyman. Lyman is 9. Okay, 9, 12 to 12, 100. Yes. Okay. This thing, okay, you have to remember, okay, Lyman series, okay, 91 nanometer to this, okay. Lyman is basically in the UV. You have to remember this Lyman is in the UV, okay. This Balmer will be in the your visible. This is the range of the Balmer. Balmer is in the visible. Rest are in the IR, okay. Others are in the IR. So this question you have to remember that Lyman in the UV, Balmer will be in the visible. Rest are in the IR, okay. Lyman, Balmer, Paschen, bracket, fund, all, okay, will be in the IR. So Lyman will be in the UV, Balmer in the your visible, other are in the IR, okay. So then this is the spectral series coming here. When it is coming to the level 1, okay, means we can say it's coming to the level 1, then we can say this is the Lyman. Coming to the level 2, this is the Balmer. This is the your given here. That for the Lyman we can say coming to the level 1 from any of the level 2, 3, 4, 5, 1. Then we can say for the Balmer coming to the level of 2, Paschen written 3, bracket is 4, fund is written here 5. Lyman is in the ultraviolet and the Paschen bracket and fund are in the infrared. Balmer will be in the visible, you can remember, okay? Yes. Balmer is having some mixing with the your visible also, okay. But we'll remember, yes, some are in the your UVs, some mixing is there, but we'll remember Balmer is mostly in the visible range, okay. So in this one, this is the thing that you have to remember here, this formula 1 by lambda, and you have done a lot of time questions like this. This is just nothing here. You can remember this second postulate defines stable orbits. What those stable orbits in which okay, both equations are valid, means number 1 and number 2. They're writing about the number 2 that angular momentum must be quantized, means it must be multiple of h by 2 pi, okay. Now electron can make transition from the higher, okay, orbits to the lower, okay, and in this one energy will be, photon will be emitted having energy equal to the energy difference all the time, okay. Here I can take one question. They will say that this is there, so we can say minus 13.6. Here you can say minus 3.4. Here I can say minus 1.5. One I can say like this, okay. So if I say here to here, how much is the difference in this one? You can say here to here difference is 10.2. These difference you have to remember. Here to here difference is 12.09, means basically we can say 12.1, I can say roughly 12.1. And here to here remember always 12.75 is the difference. They will say we are giving photon of 10.2. It will reach to the level 2. We are giving the your 12.1 reach to the your 3. We are giving here that it will reach to the your 12.75. Okay. And then they can ask the number of lines or something. So remember always number of lines are given by, in this one, your delta n into delta n plus 1 divided by 2. Okay. You have to remember number of lines. Okay. Already you know here. They can ask sometimes where is the maximum or minimum energy released. Like if I say here, when you keep on going for okay, like this energy difference keep on decreasing. So here maximum energy is there. So when coming to here, then this is the least energy. Coming here is the maximum energy released. Okay, this one is the least, this one is the max. Others will be the, of course we can easily compare max energy and minimum energy. One question is coming here. I can say that 1, 2, 3, 4, 5. 4 to 3 is the okay. They are saying in this one that 4 to 3 we are getting in this one your okay 4 to 3 is the suppose visible range is coming, okay, for a okay 4 to 3 is the visible, okay, 4 to 3 visible. They're asking which can give you which can give you UV. So you can say UV means, or which can give you your IR, okay? I can say which one can give you IR, okay? So you know that visible, here to here you are getting the visible. So for the IR, energy must be less. So lesser than this is needed, and lesser than this is only possible in the 5 to 4. Lesser than this is only possible in the 5 to 4, because all remaining will be having energy more. If you are taking any of the transition out of the given option, will be having more. So you can say answer in that case we can take 5 to 4, because IR is having lesser energy, okay? So these are the some formula here. This is the energy already written, okay? And negative means basically it is bounded to the, okay? It is bounded to the nuclei here. So here we can, okay, in this one, take some questions directly. This is, okay, energy levels written here. Already I said this thing, okay. One thing you have to remember, that after 0, if you see here diagram, after 0 they are not putting any line, okay. This diagram, okay, a lot of time we ignore this thing, that after 0 they are making this continuous. So after 0 these lines does not exist. After 0 electron become free, and electron is free, then it can have any energy. So this is the meaning of this thing, okay. This is not the okay, printing mistake or this color, okay. This means after 0 it can take any energy. It is the continuous. We are not getting the your line spectrum, okay. So it is specified also here in this one. An electron can have any total energy would be, okay, above 0 level, okay, above 0 level, any energy possible. In such situation, electron is free, then there is the continuous, okay, continuum of energy level, means continuous energy levels are there. That is not the line spectrum, okay, more than above 0, okay, above 0 electron volt, okay, that is shown in the diagram also, okay, because free electron can have any energy, okay. And this is the one simple experiment. We don't have to see also. Then again they are writing these all the spectrum in the details. Some questions like Lyman, Balmer, Paschen, Rectifier, but ultimately question will be coming on the Lyman, Balmer, Paschen, and in these all, okay. If coming to the level 1, then this is the Lyman. Coming to the level 2, then this is the Balmer. Coming to the 3, then we can see your Paschen, like so on, okay. I hope Lyman, Balmer questions we can do. Okay, because these are calculating the wavelength, so just calculations, nothing much here, okay. That's why I said wave will be, this atom will be, okay, finished very fast, nothing is much in this one. Okay, so one question I can take in this one here, okay, was in this one, yes, about the laser light, you can remember what is the full form of the laser. Laser stands for light amplification by accumulated emission of radiation. In the laser, interference is used. In the laser is the interference of n number of sources, okay. So you have to keep this thing in the mind. There are the n atom in a source, each emitting light with the intensity I. Then the total intensity by ordinary source will be Ni total, okay. I total will be Ni. But where in the laser source, it is proportional to n square I, because in the laser source all are coherent, okay. This is the, okay, why is the n square I? Because all are coherent, okay, all are coherent, so this becomes n square. That's why laser is always very, very stronger than the ordinary source, okay, ordinary source, okay. In this one, some questions I have ticked, okay, that you should do actually here, which are the means based on the line Lyman, Balmer, Paschen, and bracket. These are the 4 questions, okay, actually you should do, okay. If you feel any question to say, I will tell here. All are easy questions, easiest actually. What is the shortest wavelength present in the Paschen of the spectral? And then this is the second one, then third one, and fourth one. You should do only 4 questions at least from here, okay. You can do, okay, good. So I'm going to close this one. Then coming photoelectric effect, which will take some time, because this. So photoelectric effect, then we'll go for the your wave optics also. So let's say in the photoelectric effect, first of all, you have to remember that here in this one, that okay, this line. If electron attempt to come out of the metal, okay, if electron attempt to come out of the metal surface acquires the positive charge and pulls electron back to the metal. So this free electron is thus held inside the metal, okay, surface by the attractive forces of the ions, okay. So electron cannot come out of the surface, means this is a surface. If electron want to come out of the surface, as soon as this electron is out, what is created here? Your positive is created, and this positive will again pull back, okay. So to go out of the surface, we need some minimum amount of energy. That minimum amount of energy is known as your work function, okay. Minimum energy known as work function. This depends on, work function depends on what properties? Depends on the property of metal and the nature of its surface, okay. Your property of the metal as well as nature of the surface, okay. And which is having the your okay, platinum is having the highest and lowest is the your cesium, okay. So now we can say these are the your different okay, your materials here. We don't have to remember any one of the work function. Then these were the experiment done by the people in the photoelectric effect. They got some graph directly. We will do the graph here. I'm not saying here in this one what happened in this diagram, okay. So directly going for the, okay, first one is coming your intensity. You know, intensity is directly proportional to, okay. Intensity means we can say intensity is directly proportional to photon, and photon is directly proportional to, more photon means more electrons, okay, electron directly proportional to photocurrent. So we can say intensity is directly proportional to photocurrent. That's why current and intensity, this is the your direct relation like this. Current and this relation is always direct. You have to remember I and I relation is direct. One more thing you have to remember, the number of photons from a source. This must be remembered always. Number of photons from a source is given by 5 into 10 power 24 p lambda. Number of photon from a source is given by 5 into 10 power 24 lambda. If they say that we have this bulb, and this bulb power is 5 milli, okay, 5 milliwatt is the, okay, power, and this is having your 5000 angstrom wavelength. You have to find number of photons. We can say number of photons will be given by 5 into 10 power 24. Power we can say 5 milli, so 5 into 10 power minus 3. Lambda becomes here 5 into 10 power minus 7. You can just multiply the things, you can get the answer. Last to examination, we asked one question. The two sources of same power, two sources of same power are there. One is here, one is here, and they are having same power, but this is giving 5000 angstrom and this is giving 7000 angstrom, and not the 7, this was the something else, okay. I think okay, let's take 10,000 angstrom. Data was different. They asked number of photons emitted. Number of photons emitted. If power is same, then power same, then we can say n1 by n2 will be nothing but the lambda 1 by lambda 2. Number of photons emitted will be n1 by n2 equal to lambda 1 by lambda 2. Yes. So remember, this number of photon formula is always very useful. So we can say 5 into 10 power 24 p lambda, and intensity is directly proportional to number of photons written here. Photocurrent is directly proportional to the number of photoelectron emitted per second. This implies that the number of photoelectrons emitted per second is directly proportional to the intensity of incident radiation, okay. So more photons means more intensity, more photons, more electrons, more electron, more current will be there. Then they are saying effect of potential, means if we apply positive potential, if you apply negative potential, what happens, okay. So let's see. It is found that photoelectric current increases with the increase in positive potential, because if you apply the positive potential, it will attract the electron, so more electron will reach. So more electron reaching, so we can say your current will be more, okay. All the emitted electrons are collected by the plate A, and photoelectric becomes a maximum. Like we can say from this plate, suppose here, from here, suppose 100 electrons emitted. One more point here you have to remember, okay, that all these ejected electron have same kinetic energy or different kinetic energy. All ejected electron don't have same kinetic energy. These electrons have energy. Their range of kinetic energy is basically Ke is having range from 0 to Ke max. Means some electron have 0 and somehow maximum, means range for the kinetic energy 0 to Ke max. Ejected electron have energy ranging from 0 to Ke max. Can we remember this thing? Ejected electron have range from 0 to Ke max. Okay. So now we can say whatever these electrons are there, this side we are having your collector, means which will collect these electrons. So now we can say only highly energetic will reach. If nothing applied on this one, I am not applying anything, so no potential applied, then also we are getting the current. Here I am representing the current here I am writing V. But only highly energetic reaching, everyone not reaching. When I will apply increase here positive, if I keep on increasing the positive potential, then the current will keep on increasing, and then it becomes saturated. Saturated means because all are reaching. So if you read here, okay, that for a certain positive potential of the plate A, all are collected by the plate A, means all are reaching, and photo current becomes maximum or saturate. Okay, after this it will not increase because every electron, every ejected electron is reaching. Okay, this is known as your saturation current. Okay, when we apply negative, if you apply the negative here, then what will happen? Electron will be having repulsion. A repulsion of the, because of this repulsion, electrons, okay, number of electrons reaching will keep on decreasing, and at certain negative potential, your current becomes zero. This potential is known as your stopping potential. This is known as stopping potential. So we can say here, this is the V naught. Okay, this is known as your stopping potential. So you know that electrons, you have to suppose stop. So electrons are not coming with the all. Some is coming like 0, some is having 1 electron volt, some coming with the 2, 3 electron volt and 5 electron volt. So if you have to stop all, so what is the potential needed here? How much potential I have to apply so that all are stopped? If I apply -1 volt, then only that will be stopped. -2, then 3 will be stopped. So what is the minimum needed here? You can say minimum needed is here -5. If I apply -5, then all will be stopped. So stopping potential will be calculated by always K max. Stopping potential always you have to calculate from the K max, which stopping potential is always equal to minus of K max, we can say. Okay, minus of K max, or sometimes we can say there's a mod of K max. Okay, from the K max. Clear? Stopping potential we can say K max. Okay, divide by E, of course. Okay, divide by E we can write, because we have to, there is the energy, there is the your stopping, okay, potentials, we can say divide by E. Okay, means if K maximum is, suppose K maximum is 4 electron volt, then what is the stopping potential? -4 volt, -4 volt. If I say stopping potential is 3 volt, stopping potential 3 volt, then what is the K? Then we can say K will be how much? K becomes your 3 electron volt. Okay, so now we can say this is the first graph coming here regarding the intensity, that if we are taking different intensity here, then what happens? Then we can say this one is at the I1, this one is at the I2, this one is at the I3. So here current is more, that's why current more, intensity more, current less, intensity will be less. This is the first graph. Okay, so we can say first graph is related to the intensity. Can you remember this thing? Here 3 graphs are possible. I will draw all the graph in the board here. 3 graphs are there, so I will say here. So what we can say in this one, that first is basically like this, that this is the first one, then we can say second one, and like this we can say this is the I1, this is the I2, this is the I3. We can say here current, this is the current more, so we can say your I3 more, and then your I2, and then your I1. First graph, okay, you have to remember. Second graph we can say here that they will take the different frequency, like I can say like this and this thing. Okay, so in this case this frequency nu1, this frequency nu2. You know here stopping potential more, and if stopping potential more, then kinetic energy also more, because stopping potential is directly proportional to kinetic energy. So we can say here stopping potential more, so K more, so frequency also more. Okay, so we can say nu2 in this case will be more than nu1, but here both are matching, so we can say I1, I2 both are same, okay. Now third graph is the combination of both the graphs, means both the graph placed together in single graph. We can say like this. Okay, one here, and then here. This is the I1, this is the I2, this one is the I3 here. This one is the nu1, nu2 and nu3. Now we can say which one is the maximum. This one we can say here stopping potential more, that's why K will be more, and K more, so frequency more, so we can say here it becomes nu3 more than okay, nu1 and nu2 both are same because they are starting from the same point, so there is stopping potential same, so K is same, so K is same, so frequency also same. Here we can say both intensity are same, so we can write I3 equal to I2, but these two are more than I1, more than I1. Okay, so these are the three graphs that everyone have to remember. Okay, if they have to ask question related to the graph, then these are the graphs they can ask here. Again, going for the now NCRT. So K maximum we can say always AV naught, and then already I have told all the graphs here. Okay, this graph also done, effect of potential, negative potential. Then this one is the graph basically. Okay. One is the kinetic energy graph, one is the stopping potential graph. Both are there. Okay, so we can say here that K equal to, if I write, then we can write H nu minus phi. Okay, H nu minus phi. So if I take here in this one, this is the kinetic energy, and here I am going to take the frequency. So K on the y-axis, so we can write this is the y-axis equal to, we can say mx plus c. Okay, so your slope becomes how much? Slope you can say becomes how much? Equal to your h, y equal to mx plus c. So c negative, so c negative here, slope, okay, like this, and we can say slope is positive. So you have to remember slope is always equal to, okay, h. They can give you two graphs sometimes like this, that here one is here, one is here. We can say for both slope is going to be same, but this point will represent the work function which is having the least work function, A or B. A or B, we can say least work function is for A, so A will be much better for the photoelectric effect. Okay, A is much better for the photoelectric effect. Okay, same they can say K, for the K they can write AV naught, so AV naught equal to, we can write H nu minus phi, so we can say V naught becomes in this case H by E nu minus phi by E. So now we can write here in this one same y equal to, we can write mx plus c. So in this one we can say graph will remain exactly at digit, but here slope will be equal to, you can say h by e, and this thing, this value will be equal to how much here? Phi by e. Okay, this graph is basically for the stopping potential. So stopping potential and K, both graphs are same as it is. Only you have to remember the slope for the K h, and here this is the h by e. Okay, yes. So these two graphs also we can remember, and this is the graph written, same graph written here, stopping potential and this. So you have to remember here that okay, slope will be same. Okay, then this observation you have to remember here. Maximum K of the photoelectron vary linearly with the frequency, means maximum energy of the photoelectron depends on the frequency of the radiation, but independent of its intensity. What intensity will decide? Intensity will decide the more intensity, more number of photon. More photon then more electron, and more electron then more current. So intensity will decide the current. Intensity will decide the current. Intensity decides current, and we can say maximum K, okay, will depend on what? Frequency. Okay, so stopping potential depends on the frequency, current depends on the intensity. Okay, this is the one conclusion. Okay, for a frequency V, okay, lower than the cutoff, there is no emission. Whatever the large intensity you take, there is no emission. You have to remember. Okay, this minimum is known as threshold. We know. I will take one question on this thing. Okay, one very important 2 points are there that I have to say here. You have to, okay, copy also. Means remember all. First one, that if frequency becomes n times, then K2 becomes more than Nk1. Okay, remember this thing. Okay, if frequency becomes n times, then kinetic energy becomes more than n times. Okay, clear? K2 becomes n times, then okay, this becomes more than n times. So many times we have asked the question. Frequency becomes double, kinetic energy will be more than double. If they are asking question for the wavelength, they will say that if lambda 2 becomes lambda 1 by 2. Okay, we will not solve with the wavelength, we will solve with the frequency. That lambda 2 I can write 1 by nu 2 is basically here 1 by twice of nu 1. So we can say nu 2 actually becomes twice of nu 1, which implies K2 will be more than twice of K1. Okay, frequency n times K will be more than n times. Okay, if I say here that okay, they will say frequency was next question I am taking here, because we know intensity is proportional to current. Okay, like this relation is there. So earlier frequency was 1.5 times of threshold. Okay, it was 1.5 times of threshold. Now, okay, now frequency half, they will say like this, frequency half and intensity double. Okay, frequency half and intensity double, then okay, then I we have to say. So a lot of people think that here intensity double, so current should be double. I and I relation, this relation I and I relation is only valid when there is the ejection, when ejection happening. First you have to check whether ejection is there or not there. Ejection must be there. So now we can say nu equal to 1.5 nu naught. So now new frequency nu 2 becomes half, is 0.75 nu naught. Okay, now we know this nu 2 is less than nu naught, and if nu 2 is less than nu naught, there is no ejection, and if no ejection, current will not be there, because there is no ejection, so there is no current. Okay, there is no current. That is the point I was saying, last point written in the NCERT also, that if intensity is less than threshold, then ejection will not happen. Okay, means this one is written here, that for a frequency lower than the cutoff